It's a kitty stream. All right. Kitty. All right. This is stream number 422. Welcome. The cat was yelling at me right before the stream started, so I'm like, okay, you want to say hi to, I guess, hi to YouTube? Then that's fine with me. Say hi. All right, today I'm going to continue working on what I was doing yesterday, which was a library in Rust that implements WebSockets. So let's get back to it, shall we? So I have my tests that I'm building up for the WebSocket part. Most of the work I put in yesterday was on the builder part. So there are a ton of tests for that. And just going over this briefly again, what the builders are. Can I collapse everything? Yes, I can. All right, so we have two different builders. For the server builder, it's really simple. There's just an open call, and that calls open server, which if we open that, it's KL, right? KJ, there we go. Open server is checking the request that you get for the handshake for upgrading to a WebSocket, and if it's correct, then generating a response and then opening a WebSocket. So easy peasy, right? For the client builder, it's actually a two-step process. You have to start open and then finish open. What the start open does is it constructs the handshake requests, and you're supposed to then send that and then receive back a response. And when you do finish open, which checks the response, and if it's all good, then it opens a WebSocket. Greetings, C17R. Look at that shiny new green sword that you have. Use it wisely. Okay, so the builders basically are to construct the WebSocket, and the difference between a client socket and a server socket is the direction in which we're supposed to mask the data. So a client, that's a client, right? Client matches the data in the transmit direction. A server will mask the data in the receive direction. Hey there, Uber Unix. You are second. Great power, great responsibility. Yes, that's right. Okay, so I think that's pretty much it from the high-level point of view. So jumping into the WebSockets, the high-level view for this. So we just have one test right now, which is that if we open a WebSocket and we send a ping, that we get the correct ping. And this is for the receive direction, in other words, a server. Looking at how it's implemented, the WebSocket does most of its work right now in a worker thread, and I'll probably move this to a thread pool or a task pool or executor, you know, a better thing later, but for now it's just going to be one worker thread per WebSocket. The worker thread gets started when the WebSocket's created and gets torn down here during the drop. We use a multi-producer single consumer channel, which we hold onto the sender for, and we give the receiver to the worker thread for telling the worker thread what to do. Hey there, JT and Romania Hate. How are you today? JT is number 3, Romania Hate is number 4 in the channel today. Okay, so all the work being done by the worker, right now it is just to handle the messages which come in. I changed this a little bit from what I had yesterday. I had a then instead of a map with a try for each. This map turned out to be the trick to make the try for each work. The try for each actually comes from a different trait, which is why I didn't find it yesterday. It is for streams which carry results. So this map becomes necessary because it needs to be a stream of results in order to use try for each. And then you get a stream of result futures, which you can await. And then right here, we're tossing any errors. But that result, the fact that we're returning a result from that future, lets me do things like when we hit the exit, we can say that it's an error. And I'm not too comfortable with it being error, but it being an exit or a real error down here is what is causing the WebSocket to stop. Hey there, Pro Table Flipper. WebSocket goes well. We have ping working. So I need to add in all the other kinds of frames we might want to transmit, and then I have to add the receiver end. So the receiver end is kind of scary because it's going to require that we both read and write the WebSocket simultaneously, which means I believe I'm going to need to split this connection between reader and writer. Otherwise, we're going to have trouble because in handle a message when we are in the send, we're going to wait here sending a frame. And if we're giving the send frame a mutable reference to the connection, that means it can't be used elsewhere. So even if we had a feature that's blocking on receiving data, it won't be able to actually do its work. So probably this is going to end up getting the writer end, and then the reader end will go somewhere else. Hey there, Rambane TR. How are you today? Okay, but I'm going to have the unit test drive this development. So going back to the C++ based unit tests, I'm just going to start to pull over the other tests I have. Send ping normal without data. Let's pull that over, shall we? I think so. And I don't know how long today's stream is going to be. I've been doing longer streams lately, and I don't want to keep doing that and burn myself out by accident. Okay, I'm going to copy this part. And I think the difference here is the ping has no data. So in a sense, I can do that with an empty string. So yeah, that should send 89 hex and then 00 hex, right? Hopefully that should just work. Let's try it. Okay, why is it doing... That was weird. It was doing a cargo check for some reason. All right, it passed. We're moving on. Past the test, we move on, right? Okay, send ping almost too much data. Yeah, there's a limit to how many bytes you're allowed to send in a ping frame, which is a control frame, which means it can't be split up between fragments. So we need to make sure that the limit is observed. We can't make the frame too big. So yeah, so this is the equivalent of doing that in Rust would be to do slice x dot repeat, right? Repeat 125. That's the equivalent of that. And what's it going to tell me here? It needs to be a vector. Oh, it's okay. So not borrowed. There we go. Alrighty. And then the expected sequence is 89.7D, followed by the string of x's. So I think what I do here is I need to concatenate something on it. Maybe let's build this as a vector. Let expected output equal vec with these bytes in them. And then expected output dot append another vector. So I can say bx semicolon 125 to vec, right? Actually, can I say extend? Because extend will take ownership of the other one, right? Oh no, is it append that takes ownership of it? Yeah, so I would say mute that. Right. So then I can say expected output here, right? If I drop the as dref and yep, because we don't want the as dref is because now we're comparing vector to vector, not slice to slice. Okay. Try that. Oh, I have an error. Oh, expected output append. Right. I do that all the time. I forget to mark things as mutable. All right, it passed. Neato. Next test. So how is everybody today? I'm just gonna, chug along with these tests until I hit a test that fails, which means I need to do more work in the implementation. I know I've only done the transmit end and I've only done ping, so it's only a matter of time before I hit that. MetroDev, subscribe with a tier 3 sub. Resubscribe for 5 months. Wow. Thank you very much, MetroDev. I need to actually make a tier 3 emote so you can actually use it. Maybe I should let you decide what the tier 3 emote should be, and then you'd be the only one besides me able to use it. Okay, change the snake case. Seriously though, thank you, MetroDev. All right. And I'm not just joking about the emote idea. If you'd like an emote and I'm okay with it, then I'll totally add it to tier 3 because it's empty right now. In the meantime, enjoy using Raimu 8 Beast, which only the few chosen few can use. Okay, so this is the same except for there's a 6 here, which is too big, and so we're not going to actually get any output. I should say what here? I should say expect none for the output. Wait, I've had that set up, I believe. I mean, actually, it should also... No, it won't break the connection, right? So it should just be none. Right. Actually, you know what I'm thinking? Maybe ping ought to return an error. If that's so, then we should check to make sure these don't return errors. Here for the rust and the pets. You totally try your hand at making any more. Or maybe just let me know what ideas you might have. So there's Raimu Good, which I think you'll be able to see in the not if I say it, but in the Discord, it's a picture of me with Timbodet's hat and me doing this. So it's like a mixture of me and Timbodet. That's what people have been asking for, but I don't have a tier 1 slot available for that. Hey there, 715209. Hey, look at that shiny sword that you have. And I forgot to wave to MetroDev. There you go. All right. I think I will have this return an error because this is not a valid request, right? There's a constraint on how many characters, or how many bytes you can send in a ping. So what if we do this? Assert that this is an error. Actually, I can do better than that. I can actually give it the error type. So assert matches error frame too large. How about payload too large? Frame payload? There we go. So we need to invent that error. What? Yeah, 715209. I had to promote some people up to mod because I ran out of VIP slots, and I wanted to acknowledge at least those who are like regular viewers who have been subscribing for months. Those who are doing that and had not and been contributing in chat and all that and I couldn't assign them VIP slots because I was out of them. I had to take some of the top tier VIPs and just give them green swords instead, because you can't be both a mod and a VIP. I guess Twitch reasons that mods are by default VIPs, so now you're like a super VIP. Don't worry, there's no real expectation of you needing to do anything, but if you want to enforce the rules of the channel, then you're welcome to, since you've been around here forever, basically. All right, I need to invent that as an error. If you really don't want the sword, I can give it to someone else too. More people with power, that's right. All right, so payload too large, doesn't need any argument. All right. The payload provided is too large to fit into a frame. Okay. a function which generates a control frame, ping, for example, was called with a payload that is too large to fit in the frame. Such messages cannot be fragmented into multiple frames. It's just a size constraint, right? So this is because ping doesn't actually emit an error, so we need to change that, right? Result error. Okay, so I will probably, yeah, this is where that return came into play, right? So this should be frame payload too large, else okay. I'm also thinking that we might want to have send frame let us know if the connection is broken somehow. Although it's going to be hard right now because right now send frame just sends work to be done by the worker, and we don't know if the worker will actually be able to send it because the connection might have been disconnected by the point that it sends it. I have to figure that out. On what intervals do we send a ping? It's not at an interval right now. It's through a public API call. So it's up to the user of the WebSocket right now to send the pings. They even get to pick the data that they put in the ping. Isn't that cool? Hey there, Toulouse. Yeah. Ooh, swords. Emerald swords, apparently. Mr. Demon Wolfellow, too. Okay, so... And Dr. Padawan, how are you doing? What's am I looking at? I expected there to be error. Oh, right. These aren't errors. They're just going to be warnings that we didn't check the result. So we can just change all these to assert is okay. Right? This without the payload body is okay. Okay, and this one is also okay, but I don't want to touch the other stuff around it because I'm scared. So we're going to do that. And that. All right. And then here's where we get an error. Okay, let's run them all. All pass. Yay. Oh, the builder has a warning that we should go check out right now. Is error a default thing? No, it goes with this error crate. So thank you to my viewers who actually recommended I look into that. This is a really useful crate that will do things like automatically implement the standard error trait for your custom errors, and it will attach, I think these are descriptions or reason strings automatically through that trait, and it also supports holding onto this inner sources or inner exceptions, so to speak, with the source attribute. So just with declarative attributes, we can tell the error-derived behavior how to implement the trait. It is pretty neat, yeah. And then I was told that it's recommended to look into using this error for libraries, and for programs, there's another one called anyhow. So let's glance at that. I haven't actually started using that yet, but I'm told that anyhow and this error kind of work hand in hand, and anyhow lets you provide contexts so that when errors happen, this context string will be attached, kind of letting you know what was happening at the point that the error occurred. And it can nest so that you get stuff like that, which is pretty cool, right? So this is the context, and then this is the underlying error. So without the context, you would just get no such file or directory, and you'd have no idea what main did. But with the context, you kind of have an idea what it does. So I've been told that this anyhow library is good for programs once again, and then this error is good for libraries. Detolne made that crate. Anything Detolne just turns into gold. Yeah, I would agree with that. He's been very active in the community. He's also streams on Twitch and YouTube. Hey there, Cat Peasant. You're writing a little Twitch library in Rust? Neat. Are you going to publish it? I'd like to take a look at it. Musin has his Twitch library already. So, not that there's a competition, but we can all check out each other's implementations for you know, kind of like, even if we don't do a code review, we can always look at other people's implementations to compare. Too advanced for you? Yeah, but you'll get there. I think it's an interesting challenge to look at code that's more advanced and you're able to understand, especially if you can ask the author questions about it, because it's an opportunity to learn. Yours is just super simple. Yeah, for now, but I'm sure it will get more advanced, right? Because if you care about it and you have fun doing it, it's only natural that you're wanting to keep improving it. Okay, I was looking at warnings, right? Yeah, I have a couple warnings down here because we call ping and we don't use the results. Let's just assert that it's okay to send that ping message, right? And then down here as well, assert that it's okay to send that ping. All right, and then I wish that there was a shortcut to go to the top of the module to where that run button is. Okay, all tests pass, great. And just to check again, these all pass too. Cool. All right, so let's move on. There's going to be another one where it's too big, right? Or just right? Oh no, now we're doing receive ping. Ooh. Okay, this is one of the first challenging ones because now we have to handle the receive path. Do we want to skip that for now and do the other sends first? Or I probably should hit this head on, right, and knock this out. Otherwise, if I write too much code sending different kinds of things, and then I have to rewrite it or change a lot of it to handle receive, then I'll be unhappy. Yeah, I think I've convinced myself we should hit this head on and figure out the receive path stuff. Because if I get the receive path working with the transmit path, then we've essentially gotten all the challenges down, and it's just a matter of filling in all the extra detail, right? Okay, so this is going to be a client, so it is mass direction transmit, right? I think I did this on purpose because then we don't have to worry about the mask being involved in the frames, so it's easier to read the content of the frames. Okay, so the way this works is what? I had multiple pings. Oh no, this is a callback to receive a ping. Yes. So I need to decide, do I do the same design where we set callbacks? Or do I have some kind of future or a stream? The stream sounds good to me. That if the WebSocket implemented stream, then the items it would generate would be messages, and one kind of message could be a ping. I think that's maybe what I'm going to do here. It's going to be kind of scary because that stream is a trait that I'm not familiar with implementing yet. So maybe I'll get some help. Maybe we'll just figure it out. We're going to do the same thing that the framework in the C++ tested, I think, is where when we receive a message, we'll just push it into some kind of vector. And at the end, we can just compare and make sure that it matches, right? Yeah, that we should have one ping. And what is this? Oh, right. I believe I have it set up so that a ping causes a pong in the other direction automatically. I should verify that. 'Cause that's what that test seems to indicate. Ping. Yeah, here we go. If you receive a ping, send a pong. Yep. All right. That's good. So that for every ping we send, no, for every ping we receive, we should be sending a pong. Why does this only check for one pong, though? I don't know. It should have like, it should go through the original ping list and make sure that the data matches, shouldn't it? Maybe I just got lazy and it's hard-coded the expected pong. Did you ever finish the framing? Yes, we did for the send. It actually looks kind of neat. So here's the framing. We take the payload length, so we know how much memory maximum we'll need to allocate. So this is pessimistic estimate of 14 bytes extra for the case where the length is so large that we need 8 bytes to encode it, right? And also assuming that we need to mask it, which adds another 4 bytes here. So the framing is essentially the first byte is the fin flag plus the opcode. And then we figure out if we're going to be setting the mask bit or not. And then when we encode the length, the first byte is either the length with the mask. There's always a mask in the first byte. But depending on what the length is, we either encode the length with 1 byte, 2 bytes, or 8 bytes. And for the 2 and 8 byte, for the 2 or 8 byte possibilities, the first byte is a marker of some kind, right? So should have written documentation. AutoMod was very cautious about that one. Should I write documentation here? I suppose I should. If I feel the need to explain this, then I think we will. So, pessimistically allocate enough memory for the frame in one shot. Pessimistically, meaning we might allocate more than we need. Allocate enough memory for the frame in one shot. Okay, then construct the first byte. Fin, flag, and opcode. Okay, then determine what to set for the mask flag. And, oh yeah, this for this flag here. I guess we'll have that in a second part of the comment here. So, encode, right? Encode the frame length, or it's really the payload length, not the frame length. Encode the payload length differently depending on which range the length falls into. Either 1 byte, 2 byte, either 1, 2, or 8 bytes. For the 2 and 8 byte variants, the first byte is a special marker. Also, the mask flag is added to the first byte always. All right, that's actually why the first byte only has 7 bits of the length, because the top bit is the mask bit if present. All right, so then the next would be add the payload. If masking, we need to generate a random mask and XOR the payload with it. All right, so here it is a generate a random mask, 4 bytes. And then here is include the mask in the frame, and then apply the mask while adding the payload. The mask byte to use rotates around 0, 1, 2, 3, 0, 1, 2, 3, 0, etc., etc. The mask is applied by computing XOR exclusive or bitwise. One mask byte for every payload byte. Okay, and then this part is write the frame, or push the frame out, right? Push the frame out to the underlying connection. Note that this may yield, this may await. I don't want to say it. There's an await here, it should be obvious, right? This may block, I guess. It doesn't technically, I don't want to say block because it's an async function. So it doesn't block. I either want to say yield or, yeah, why don't you just say yield? This may yield until the connection is able to receive all the bytes. If any error occurs, consider the connection to be broken. Right? The other way we would consider a connection to be broken is if when we read, we either get an error or we get it completed with no data, even though we had a buffer. So we'll handle that a little bit later. All right, so there we go. I should have written documentation, now completed. It's now documented. And that is the frame, the sending of the frame. We still have to do frame receiving, which we're going to do pretty soon, right? Because I'm adding this test to receive a ping. Okay, maybe we'll just do the same thing right now. Let pings equal vect new. And I'm going to, I think I'm going to go through the stream approach, which means that we will, in order to receive a ping, instead of providing a callback, we will need to actively try to push to completion a feature which is going to receive the pings. So, yeah. No delegates then. I guess I just make a future at this point, right? One that we will try to drive to completion reading the streams. So let stream ping reader, let reader equal async. And then we need to, we're going to borrow ping, we're going to be pushing into pings, right? So this should be ref celled, I think. You have to be careful because this async block, depending on, I guess I can, you know what I can do? I can just drop the reader when we're done. Maybe I won't need the ref cell. I might need a ref cell if the lifetime of the reader extends past where we're going to be using the WebSocket. Hey there, Lazy Guru. How are you doing today? Okay, yeah, the async block here is going to... You got a diamond, yes. I updated the VIP status, so folks who were VIP but haven't been around in a while, I took their VIP diamond and gave it to people who have been here recently a lot. The cat walked on the keyboard. The beginning of my stream, you got to see my cat. If you want to see that, check out the VOD. You see minus, greater than, less than P. Okay, I can see that. There's the two paws, so that the less than the greater than signs were the left paw, and the minus and the P was the right paw, or unless the cat walked in the opposite direction. And then enter, and then left bracket. I think the cat walked forward from the bottom of the keyboard up. That's my guess. Cat activated keyboard forensics. Hey there, Epic Unknown. How are you doing? And Marco Dev. Yes, home, bin, cat. All right, so how do we read a stream? It would be ws dot for each, I think. Yeah, for each message. Envisioning that WS is a stream that we can call for each on, right? Hey there, Gartuals. /bin/cat. Not found. My cat's not to be found right now. I don't know where he is. He's lurking somewhere. What to put here? Ultimately, we need to do a pings.push message, but only if it's a ping, right? If let ping, it would be message type ping. If this is imported from the crate. Yeah, let's imagine we're going to invent an enum called message ping. Then push the ping into there. Else, I don't know what we're gonna do here. I guess panic? Panic! Ah! We got something that isn't a ping. Okay, this isn't going to compile at all until later, right? What async library am I using again? Let's see. I've been favorable towards async standard, but instead of Tokyo, but I'm trying to avoid them if possible and just stick to futures. Yeah, so for my testing, I use async standard, but if I can avoid it, I do, and I just stick with futures. You have to compile your cat and install. Okay, so we'll get to this later. Maybe I'll comment it out for now. Okay, and then that's the equivalent of that, right? And then I don't need to set delegates because we are like using the stream as if it was an asynchronous stream. All right, so then also as I like cats, I guess you will not put her in optional directory. That's true. Okay, let frame be binary that. Okay, so this, the equivalent of that in Rust is to go through this backend and have a way to the WebSocket, let's call it WebSocket input frame, I guess. Should we just borrow frame? So that doesn't exist yet. Okay, and then we're basically checking to make sure we get the ping we expect. So I think I should try to drive reader to completion here. So reader dot await. Well, I need to put this inside of an executor, don't I? A block on one of these guys. Block on reader await. And then we will check to make sure that the WebSocket output had the pong in it. So I already have that here, right? Expected out, well, the easier one. This one. So this ensures that we get back out world. Oh no, this one. Sorry. That is the pong, right? Oh, wait a second. It's that plus a bunch of masked stuff, so we need to construct what we're going to get back. Hold on a second. Let me check something. All right, sorry about that. I'm gonna need to take like a couple minutes break in a little bit because I need to move my vehicles. All right. You amazed how fast I could become so proficient in Rust? I hope I'm proficient. Jeez. Maybe it's imposter syndrome, but I keep feeling like I'm not writing it the right way or the best way. People in chat do help me and catch me when I do things that are wrong. I actually want to build it this way, I believe. I want to build the expected output here and start with the 8A68. I mean 86, and then yeah, we have to take the next 6 bytes, which is world, and then make sure it matches the mask. So I would wouldn't I want to initialize, well, oh wait. I didn't check the whole out, right, because the mask could be anything random. Yeah, so we would get a copy of the output instead of getting an expected. So let output equal that. The type of this is going to be a option. So we should assert that it is sum, and then let output equal output unwrap, and then assert equal essentially this, right? Move this up to here. that we get those for the output when we slice it and get the first two characters. So I ought to make sure the length is correct here. Assert equal 8, right? 2 for the header, then 8 for the 2 for the mask, and then 6 for the data. That's not 8. That is 10. Output.length. No, it's even more. 6 plus I, so it's 12. 1, 2 bytes. Oh yeah, here it is. Why is it 12? 1, 2. Oh, the mask is 4 bytes. So 2 plus 4 plus 6 is 12. Yes, okay. So 12 for the length. Then make sure the header is correct. Then for each of the data bytes, right? So for I in 0 to 6, assert equal. Well, I can copy this basically, right? And then I don't need these. Did I already do that? No, I didn't check the pings yet, but I am going to check these things. All right. So it will be output. Oh, frame is frame. Output goes instead of this one. Okay, and then the types are wrong, right? Wait, why is it expecting oh, no sum? That is wrong. And now what's different here? Both need to be references. Does that mean I don't actually technically need that and I can just do that? Compare the two slices directly? Almost. This is a size and this is unsized. Okay, so I still need that annotation. And that's not even correct. Wait, we can't compare arrays. Oh, this is a reference. So what if I dereference that? Hey, that works. That's sort of goofy though, don't you think? I guess the other way would be take a slice. Yeah, maybe that's better. Okay, and then this is making sure the header is correct. This is making sure the data is correct. Looking at the mask here. So should I annotate that? Data mask. So verify masked data is correct. Mask is random. Verify the WebSocket replied with a pong containing the same data that was in the ping we gave it. All right, so this is the pong. Actually, that's fine. Verify the header is correct. We shouldn't say verify, we should say receive back the pong message, which the WebSocket should send when it gets the ping. Verify the header is correct. Should I say verify the size is correct here? Verify the mask data is correct. Mask is random, and then we can also check to make sure that we actually got the ping. Yeah. verify the ping was delivered back through the output through the WebSocket stream interface. So again, I had that commented out, but what it's going to do is push it into pings. So we should get back, we should just be able to make sure that the vector matches, right? So this is assert equal, and then for this I can just say vec, right? World pings. Whoa. I hit a strange key combination and now I lost my desktop. Shoot. How do I get my desktop again? Desktop 1. There we go. I must have hit Control Win left, yeah. You saw my nifty background for a while. Sorry about that. It's just to wake you up, you know. There we go. All right, so I need to add this interface WebSocket input to my mock, and then I need to make the reader a valid future. This should work though. Why is this not working? Oh, it's saying reader is not a feature? Oh, shoot. I just need to do reader, right? Yes. Okay. I see that you haven't gotten used to the new keyboard. I have, but my fingers slip. The Primogen has been here 1 year. Hi, Primogen. How are you doing today? And hey there, Panapudi. Thank you for 12 months in a row, Primogen. Howdy. Hey, look at that nifty pink gen that you have next to your name. You guys should really watch the Primogen. Hopefully you watched him yesterday when I rated him. Such an entertaining stream. All right. I'm in the depths of Rust trying to make asynchronous stuff. What's the right word for this? Asynchronous code block? I'm trying to make an asynchronous code block that we can drive to completion here to read a stream of messages back from a WebSocket that we're creating from basically scratch. So I need to do a couple things. The WebSocket has to implement the stream trait so that I can do this for each. And I have to invent a message type. And I need to provide a way for, this is the back end of the mock connection, basically a way to inject data for the WebSocket to receive. So the idea is the WebSocket receives this input frame here of bytes, and it should translate that as a ping, which it should do two things. It should let us know through the stream API, the trait, that we got a ping, and then we should be able to take the contents of that message, which is world, and put it into our vector, which we compared down here to make sure we got it. And the second thing it should do is send back a pong, which we'll be able to get back again through the other end, the other direction of the mock connection when we receive the output from the WebSocket, that we should receive a 12-byte sequence because the reverse path is going to be masked. We check the header first, and then we'd make sure that the data is correctly masked. Since the mask is random, we just apply the mask to the data to unmask it again, because that's the property of exclusive OR. You apply the mask twice and you get back the original data. Nifty how that works. We should make sure that the output matches the frame when it's masked. So yeah, this is the original input masked, and this is the output. There we go. So that rows and columns, right? The data and the mask, make sure the original input mask matches the output data. I am writing WebSockets. Check it out. We have the half of the frame protocol done. So walking through it really quickly, allocate memory for our frame. We do the fin flag and the opcode. We set up the mask bit, and then we encode the length. Is 3 different variants for the length, right? 1, 2, or 8 bytes, and here's where we plug in the mask with these placeholder bytes to mark which variant it is. And then we either apply the mask to the data or we don't. Either way, we're appending the data, either directly or by pushing a masked bytes in, and then if we're masking, we are generating a random mask and pushing that into the frame as well. And then it gets all written out to this connection in one line of code. 125, 26, and 27. Yes. Actually, you know what I think I ought to do is instead of doing OX7E, I should just put 126 there, right? And then 127. That might be more clear. That's why you can't encode 126 in 1 byte, because 126 is a special marker. And we need another special marker for the 8-byte variant. So I didn't invent this, of course. It's all talked about in the RFC. What does frame 126 plus mask mean? Plus, you can do plus to combine bits together in a byte, right? So the mask bit is either going to be mask, which is hex 80 or 128. It's either going to be 128 or 0, depending on if we're masking or not, right? So we are taking the value 126, which is binary of 0, 1, 1, 1, 1, 1, 1, 0, and then adding 1, 0, 0, 0, 0, 0, 0, or 0, 0, 0, 0, 0, 0. See how that works? So we're either going to get, right, 1, 1, 1, 1, 1, 1, 1, 0, or we're going to get 0, 1, 1, 1, 1, 1, 1, 0. So this top bit is the mask bit, right? When we add the mask bit, it just goes into place. If we're not adding the mask bit, it stays unchanged. So you could also do it with a bitwise OR, but I tend to just use plus because it means the same thing when the bits don't overlap. Have I looked into Autobahn? Yeah, someone recommended that I try that in my test suite yesterday. That was 715209, who is now a mod in this channel. Congratulations, 715209. I will get to that. Right now, I'm just using my own test suite. This hurts your brain? What, to add bits together? So that's 126. So there it is again, right? This is 126 plus 128, right? I'm doing it in bits so you can see and match it up maybe with the RFC for WebSockets. This one. When we talk about the data framing right here. So it's this byte here, this byte here from bit 8 to bit 15, right? We want to put the payload length in the lower 7 bits, and we will put the mask bit in this upper bit here. So this upper bit is 80 hex, or 1 and then a bunch of zeros, right? That's the mask bit. So it's either going to be that or it's going to be that depending on that, because it's either 0 or mask, which is 80, right? But you can think of it as just we're adding bits together. We're adding this value with the mask bit, right? We're adding 127 with the mask bit there. When I constructed the first byte, I did so by adding the fin bit with the opcode, because the fin bit is either 0 or 80 hex. And you might ask, why is fin and mask the same bit position? It's okay. It's okay. They're in different bytes. So fin is in the first byte as the high order bit, and mask is in the second byte as the high order bit. If we use these reserve bits, they would be 40, 20, and 10 hex. And opcode, we don't need to shift around because it's already in the low order bits. And same thing with the payload length. Isn't that convenient? We don't have to do any shifting of bits. It's almost like it was designed that way. You recommended it to me last year. I think I looked into it, but then it wasn't trivial to add to my C++ test suite. So maybe we'll try again this year for Rust. You don't trust plus versus... Yeah, so the difference between plus and OR, bitwise OR, is bitwise OR does not carry from one bit to another. So it's equivalent. That is equivalent to this only if, sorry, these are equivalent if these bits don't overlap, which is true. If they do overlap, then you should, it depends on, do you want the bits to carry or not? If you want them to carry, you use plus. If you don't want them to carry, you use that. If they don't carry, then they get squashed together. If they do carry, then This means that if you have a 1 bit in both sides of the plus, it will carry into the next higher order bit. So it's some of it's a personal preference. Because we know that the bits don't overlap, I was just sort of lazy about it and did plus, because conceptually we're adding those bits to those bits. They're mutually exclusive. No, that's not the right term. They are, what's the term, like when they don't intersect at all. They're on like different, they're tangential, not tangential. Oh, the mathematical term that escapes me. Orthogonal. They are orthogonal, right? Did I get the right word? Sometimes I don't use the right words. Define orthogonal, please, Bing. At right angles to each other. Yeah, so it's like X and Y axis in a sense. So when you think about coordinate systems, if you have an X coordinate and you have a Y coordinate, you can think of your coordinates as XY, or you can think of it as X plus Y if you're doing vector calculus, because these two are orthogonal. So you can add those together, because internally this is a quantity in one direction, like up down, and Y is or left right, and then Y is an up down direction. So you can safely add vectors that way and get a composite vector. That's how that's my thinking for using plus here, because I know these bits are orthogonal to each other. I can add them just like I do with vectors. So asymptotic? Is that a synonym for it? It could be. Please don't shift our bits on string. We're not shifting it. Okay, there are some shifting of bits, but this is because I'm too lazy to figure out the byte order, right? If we said it was a big endian versus little endian, we could store them directly by casting. I think there's some built-in casting operators in Rust, so you can say, take this U16 and store it in a U8 vector, assuming big endian or little endian order. I was too lazy to figure that out, so I just copied what I did in C++, which is pull off each bit one at a time. We know that's a high order byte because we're shifting it down, and then we're truncating it. So we know that that's the high order byte. I did have to suppress the warning about the truncation, because Rust is like, wait a minute, you're losing bits here. You don't want to do that. And I'm like, yes, I actually do want to do that. I want to lose the upper bits. I only want the lower 8. Anyway, did I fully butcher that to death? I have hurt everybody's brains. So maybe by popular demand, I could do that, I wouldn't mind it terribly. If people think that that's more appropriate, that we're bitwise ORing it into place, I just think it looks weird. I mean, but our test will still pass. Here, let's check. This is why I have unit tests. I can run them and show you that it still passes. Except for I was in the middle of working on this test, and I wasn't done. So maybe what we'll do is we'll just comment out this test for now. I don't want to wipe out the test. I just want to comment it out. Thank you. Editor. It's almost like, see, I don't even need ASDF and xrandr Primogen, because I screw up my keyboard all by myself. See, look, we pass all our tests. So that proves to me that it was safe to do inclusive OR there for the opcode, and there for the oh, I missed one. Just to be safe. So we're not pulling any funny business. Run the tests again. Yeah, still pass. Just got done writing this protocol recently. So yeah, did I make any mistakes? So far, I think it's correct. It's really not that big a deal. You just have a 2-byte header. Well, a single byte opcode with fin flag, and then you have header bytes, either 1, 2, or 8, that encode the length and the mask flag, and then you have optional mask, and then you have the payload. So that's it. It's a pretty simple thing. They're the same operation only when the bits are orthogonal. So I would have to encode, if I used a plus here, it might be fair to say I would need to say plus is okay here because the bits are orthogonal. Right? But maybe using bitwise OR is better, because then I don't need to say that. It's pretty much implied when you do that, that they had better be orthogonal, otherwise you're going to squish things together and lose information. Isn't everything you send just one frame? the ping is 1 frame, but when you send larger text messages, they can be fragmented. So that's what the fin bit is for. It is set if it's the final fragment of a message. If it's not the final fragment of a message, it'll be a 0. So a text message that won't fit, that doesn't fit in the it's actually up to the it's up to you as the implementer of the WebSocket how large you want to make your fragments. But because you can have one that just fits in one tremendously long frame, right? The problem with that is if the frame is tremendously large, you can't get any pings or other control frames in the middle of your tremendously long frame. So what I've seen done in practice is you cap the length of a frame for data, and then fragment any messages that are larger. So the fragmenting allows you to let's see if I can show you this. If you have a huge, super long message, let's pretend each one of these X's is like a megabyte. You could send that, and then maybe while you're sending that, you had a P for a ping in there. Or what you can do is instead you can decide to fragment that into maybe chunks like this size, right? Actually, the way I'll do it is copy this, and then for every 4 of these, I will put a space character, right? So now what you can do is you can put that ping closer to where it needs to be, right there, right? Go put the ping right there. So the ping would make it through faster because you only need to transmit those 8 fragments, or these 2 fragments, right? And then you'd be able to send the ping that you wanted to send, and you wouldn't have to wait for the rest of the data to go out for the message that the user wanted to send. Whereas if you didn't fragment, you'd have to wait for all of those bytes to make it through before you could send your ping. And that by that point, the other end of the WebSocket might have, been impatient and disconnected you because you forgot to ping. But did I fragment my messages? I think I did in my C++ code. I think the way I did that, and I haven't done it in Rust yet because I haven't added this yet, is I have a way to configure the frame size. Let me check, because I'll need to know this anyway in a bit. I think what I did, yeah, I had a configuration. Yeah, configure. Let's go to that. Yeah, max frame size. Maximum allowed incoming frame size beyond which to receive the data causes immediate... Okay, that's not it. Okay, I take that back. Maybe I never did do fragmentation for transmit. You have to support a reassembly of fragments on the receive side, though. So even if we don't fragment on transmission, we have to allow it to be fragmented by the other guy. I guess I never got around to doing message fragmentation. Maybe I should make a note about that. Notes, we never gave the user the ability to set the fragmentation to configure transmit message fragmentation. And this is too long. Shorten. Actually, if I... where's my scroll bar? Give me my scroll bar back. Okay. We might want to consider adding this somehow. I don't know. Maybe we will. Maybe we won't. I don't know. Never send more than 1480 bytes of data. Why 1480? That sounds like a magic number to me. Is it not possible this way to fool the socket by sending bad data? Well, the WebSocket doesn't care what the payload has, right? So the only thing that would be considered bad would be something in the header, and you would know within the first 14 bytes if it was bad or good. Now, the length might be tremendous, and I might say, yeah, we'd like to send you a 4 billion character, byte long message. And as a receiver, you might be, do we have time and space to receive a 4 billion byte long string? Sure, because we got 16 billion bytes of free memory. So the definition of bad versus good, I would say definitely within the first 14 bytes, you'd know if it is definitely bad or not. Beyond that, you'd have to consider subjectively, is the payload length so friggin' large that you're not willing to accept it? Then it might be bad for you because you didn't want to accept such a big frame. But it might still be considered good by the pure definition of the protocol, right? As long as the payload length matches the payload data's actual length, and you follow all the rules in the header, it's considered good by the protocol, even if it's so huge you would never want to receive it. Hey there, Chillmaker. How are you today? Oh, Ereld, hello. I forgot to say hi because it's in the middle of that big long explanation. Yeah, plus and bitwise OR are the same for me because they're orthogonal. But we're switching to bitwise OR, I think, because it's maybe better documentation-wise. And hey there, Pick and XJ, hello. Okay, Sai actually asked the question, what's the name, concept, or abstraction that handles the different connections in TCP protocol, if that is a thing? That is called there are two types in Rust, the TCP listener and the TCP stream. So we handled that back in HTTP library. I can show you really quick. Or was it in server that we did that? Yeah, it was in server. All right. So we have TCP listener. This type in Rust is how you receive incoming TCP connections, right? That's the abstraction. Now, how it's implemented depends on which library you pick. I'm picking Async Standard Net or Async Net. You could pick the one from Tokyo, whatnot. But I believe it's either it's a standard or it's a de facto standard. You basically bind it to a port number, and then you tell it to accept. Accept, which you have to wait for, will give you back a connection, and then this thing is a TCP stream, which is the other value, which is the abstraction on top of a socket, basically, a TCP socket. And it's also available from the same libraries, Async Net or Tokyo or something else. And the way the TCP the connection or TCP stream works, it's sort of implied by that part of the name stream. It implements the trait in Rust called stream, which we can find out more about if we go to futures. Stream. It is like an iterator where each item is, in this case of TCP, it's a bunch of bytes, and it can be either synchronous or asynchronous. So if you use the asynchronous TCP stream, you get an asynchronous stream, where each time you get something, it's instead of blocking you call it from an asynchronous context and you yield. But you can also go and pick the from the standard Rust, you can pick the stream as well. And why do I have Dark Reader on here? Should not be on. There's the standard one, which is blocking. So it's still a stream, and so you still handle like an iterator, but you don't need an asynchronous context, and every time you read this TCP stream, it blocks. So you pick what's your poison, blocking, non-blocking. Roughly equates to synchronous, asynchronous, right? Same interface as TCP stream, which implements the stream crate. And it should say so. Am I wrong about that? Is stream an asynchronous only concept? I might be wrong about the stream thing. I think I am wrong about it. Okay, so synchronous, you'd use read and write. Yeah. For asynchronous, I need to actually go look at like async net and show you that. So you look up TCP stream and it will implement stream. Am I wrong about that too? Gosh dang it. I think I'm misled by the fact that it has the word stream in it, so it doesn't act like a stream. Oh, it's async read, async write. Okay, then forget everything, not everything, but forget a lot of what I said in the last 5 minutes. TCP stream, whether it's synchronous or not, the API is read and write, or async read and async write. I think I'm getting confused with a stream with channel. That's what I'm getting confused with. Which maybe that means for the API I use down here in the code I'm writing at the bottom, I should be using async read instead of stream. So instead of for each, I would do a read. I kind of want it to be a stream though, because each item can be a vector, whereas read and the read API, I believe, or the async read, it is it's more about like you say how many bytes you want, right? Okay, the async read, it just gives you back some. No, you pass in a buffer of some size, yeah. So you get to set whenever you actively read or write what the size of the bytes is, whereas with a stream, the item for a TCP, not that one, for a stream, I'm already there. The item is one thing at a time, so usually it's a one vector at a time or one message at a time. When you thought 2020 was bad enough, now in Denmark, they found that corona spreads to minks, is mutated, and can jump back to humans. Oh no, who's going to protect us from the minks? Hey there, Leafless. Okay, John Mega, remember they told you the issue you had on Friday? You found out the issue was that you were looking at it wrong, your brain didn't want to change about it. See, there you go. Taking a break maybe helped, right? The weekend helped. The issue you had is that you thought it was just converting from a tree of type A to a tree of type B, but it was more like a list of trees, which you need to convert to a list of processing steps, which then need to be combined into a tree based on common steps in it. All right. It's a bit more it's a bit more, what's the right term? That's a bit more than my brain can handle right now. I have to admire you, Joe Mega, for being able to work on that kind of stuff. I don't think I have the capability to think that deeply about compilers. Yeah, maybe in the past, I would need to probably restudy compiler theory and stuff to get that again. All right, back to what I was doing. Oh, so Primatine, you're saying the MTU being 1500, you probably want to keep your frame below that. Yeah, that's probably a good idea. Otherwise, you'd fragment it twice, right? Do I still have that? I already closed it. I closed the buffer that my example was in. But yeah, say you had your long message to send over a WebSocket and you said, hey, yeah, it's a good idea probably to fragment that. Let's pick an interval of, say, why is this highlighting it? Say an interval of 5 of these, right? And you say, okay, let's fragment at that boundary. And then TCP says, those are too big for me to eat. So I'm going to furthermore fragment those at the TCP layer down to that. Then you're going to find yourself saying, well, we sent this many packets where we could have sent half that many, right? And each packet wasn't full. So you're effectively wasting, well, you're incurring extra overhead for each of these packets, right? So yeah, if you had originally set your frame fragmentation at the WebSocket level to something more reasonable like this, then TCP would be like, oh yeah, each of those packets is not too big, not too small, just right size, and we don't need to refragment at the IP layer. So yeah, what Primatine said is correct. The maximum transmit unit, or MTU, defines at which point along the connection between your client and the server, if the packets are greater than the MTU size, then they get fragmented, which incurs extra overhead because every fragment is its own packet in its own right, which needs its own IP header. Never studied anything about compilers? See, you're just learning the stuff that you would have learned by studying compilers. Well, yeah, going the logical way, I'm sure you'll approach the same theory, right? Yep. Okay, what was the last thing I did here? Right, I changed those. I think we want to go back to working on the receive side, though. Oh, thank you, Leafless. I try. And if I'm ever wrong, let me know, and I will stand corrected. I'm perfectly happy standing corrected. Okay, so I need WebSocket input on the backend. What I did last night after my stream, I was kind of bored and wanted to do some coding. I took my mock connection and moved it to its own module so that I could reuse it. It's pretty sweet. So now this module mock connections has the back end of our mock and the front end, which is basically it needs to implement async read and write. And the only thing we're really doing is saying you'll never finish flushing or closing or reading, but you'll always finish writing by we take what we write and we pass it to the backend through a channel, which we give you the option of receiving back out through this WebSocket output will block on receiving from that channel whatever messages get sent by the WebSocket. So I need to add to this WebSocket input, which is the other direction. So let's put it here. A pub function that, and it needs to be mutable. And then we need to have the frame. So this is in the other direction. Let's say it's an into vec. So I'll do a T and say it's generic because that's a good thing to do. Where T is into vector of bytes. That way it doesn't have to be a vector of bytes. It could be a slice, or it could even be a string. Anything that's convertible into a vector of bytes. This should be frame or input. Input? Sure. See how Rust FMT formats it automatically for me now? It's sweet! Okay, so what are we going to do with this input? First we have to actually make it into a vector. So that's the into. The into function goes along with the into trait. It basically says this is basically saying is this input parameter can be anything which implements the trait into vector of bytes. The into trait exists so that you can say for any other type, like let's say a slice or a string of characters, if you implement the into trait for something, for string or slice or something like that, it means that we can pass a string or a slice or whatever we implement this trait on in place of this input, as long as we do the into to get it into the vector form. So a vector implements into vector by doing nothing. So the into, if we passed a vector we already have allocated into WebSocket input, this would do nothing. But if we passed a borrowed slice, for example, for the input, this would actually be the same as if we had done vec new input, right? So it would create a new vector based off of that input, or yeah, I think that's what it would be, as long as new accepts a slice. Actually, it might not. It may be from, right? I can't remember the syntax, but essentially create a new vector from something, which would be another memory allocation and a copy, probably. Whereas if it's already a vector, this is a no-op, so it's much friendlier. I'm over-explaining it. Sorry about that. I will try to keep it down to one over-explanation per hour. So, why didn't it accept that? Oh, the frame is already a slice, so I don't need to take another reference to it, right? Because frame is already a borrowed array of bytes. Oh, did they not implement into vector for an array? What if I do this? Then it works. But pings doesn't work because we don't know what the type is yet. This error is because we haven't said what we're putting in yet. We're going to keep count of the explanations? Yeah. Please do. I guess we can work on this next. Well, I need to fill in something here. We need to do something with that. What if I do to do because I'm lazy, so we can do it later? All right, then I can uncomment that. For each doesn't exist because we have not said that we implement stream, which is I'm going to do now. Yeah. WebSocket. Yeah, in the same file, right? Where's WebSocket? Here's WebSocket. So there's our normal implementation. We're also going to implement stream for WebSocket. This is where I'm going to maybe get a little bit scared because I'm not actually sure how to do this. I need to import stream from futures, right? I think it's stream. Yes. So I should get the yeah, get this ready because this is what we're gonna look at, right? It's actually in the prelude, huh? Interesting. Stream! Isn't it polling and waiting? Sort of, because it's asynchronous. Fundamentally, we got to do poll next, looks like. So go down to here, and it will we'll use our handy dandy light bulb to implement Excuse me, implement missing methods. Yeah, so we need to implement poll next. So that means I need to dive into the world of futures. Futures in Rust have this convention where you will, to get the next item from the stream, the syntactic sugar that you do, like with the stream extensions, like doing this for each, for example, it's going to de-sugar down to calling this poll next and expecting to get a poll result. And the poll result can either be that we're ready to deliver an item or we're not ready. And if we're not ready, we're supposed to take this context and register a waker, something that we can call when we become ready. So this is where I need to maybe do some reading. Or maybe I can just wing it and see if I can do it. We need to declare what our item is. So yeah, on our item for a stream, I'm thinking is just a vector of bytes. Right? And then this is an option in order for the special case where the stream ends, we return none. Speaking of streams, what size data make y'all start thinking about sending your data via streams? I'm going to use streams because I think of a WebSockets items as actually, it shouldn't be vector, it should be message, right? I already said it would be message. Put a bookmark there, because down here we say what we want, right? We want this to be something which is a message type. Should I call it message and remove the type? How about WebSocket message? That's even better. That's a better name. So yeah, the things that could go across the WebSockets are WebSocket messages, right? So let's invent that. Enum WebSocket message. Obviously, one is the ping, and then the message inside is going to be a vector of bytes. Because it doesn't have to be Unicode, it can be anything, right? When we talk about text messages, though, it's got to be a UTF-8 string. When we talk about binary, where again, it has to be a U8, right? And why don't I just keep filling this in, right? Why not? A pong is also a UND8 vector. And the other one is close, right? Although close, you can say we should handle internally. I don't remember if I handled that externally in the C++, so I'm going to look. It would be in my delegate array if it was, so let me look at my delegate. Okay, yeah, so there is a close receive delegate. So there's the message received. Close. All right, here we go. Ping, pong, text, binary, close. All right. So we have ping, pong, text, binary, close. And close had something strange in it, right? It had a code and a reason. So let's put code, which is unsigned integer, and then reason, which is a string. There we go. You don't necessarily have to have a large data use case to use streams. You could also use streams to keep your socket open and use that instead of polling. And then would each item be a single byte then? Because then it seems like it would be a wicked amount of overhead. Unless, like you say, that your socket is a stream of vectors of bytes, but then who gets to decide how big the vectors are? I think that's why I was wrong before when I said TCP stream implement stream. I think they implement read and write instead, because read and write give the user more control about the size of every read and write. Whereas a stream, you have to pick a type for the item, right? You have to do that. And so what would you pick for a TCP stream? Would you pick U8? Would you pick vector U8? And if you picked vector, then how big is each vector? By implementing read and write or async read and write for a socket, a raw socket, it lets the user have more control over how many bytes are lumped together into an item, I guess. More in response? Okay, yeah. I guess I'm just thinking out loud. So for a WebSocket, it's clear that these are the types of messages, so I think it is more appropriate to use a stream where the item is one of these guys, right? Your question was more about 40 gig-ish data. Yeah. I think then good best practice is what Primogen was saying, to consider your MTU around 1500, no more than like 1440 or whatever, because the MTU is at 1500, so that your packets don't get fragmented. Because packet fragmentation is extra overhead you don't really need or want, right? Unless you really, really, really want to shift the burden of breaking up your message, down to the lowest layer, and then more power to you. You know, I don't. The protocols are flexible for a reason, right? Maybe you don't want to fragment and you want to let the IP layer do it, or maybe you don't want the IP layer to fragment, so you'll take care of it yourself by being MTU conscious. Okay, I'm scared of this. What am I going to do here? Solutions I thought about was chunking gzip and streams. Chunking, yeah, in HTTP, the chunking is pretty painless way of doing it, and also lets you be free of the burden of needing to know your content length in advance. Gzip is going to be a stopgap, or it just makes things a little bit smaller sometimes, but you'll still have things that will, even gzipped will be huge. Streams, yeah, gives you the opportunity of breaking it into units, but then you have to decide what your unit sizes are, obviously. Okay, so what do I do here? I guess leave that to do and let the unit test drive me. I just need to get this to work. So this doesn't work, why? If let, oh, I need to do an equal, right? Equal message. Yes. And then this for each doesn't work, why? Oh, because this isn't an async block. Is that why? Yeah, there we go. Now we got errors elsewhere. Okay, we can't compare vectors, apparently. Well, it keeps going away when I try to... Okay, can't compare a slice... Oh, okay, yeah, this... We can just... I can be lazy and do as bytes. Alright. Lazy wins this time. Okay, now what's wrong with this? Capture... Okay, this means I run afoul of the borrow checker when using a closure. So what are we capturing that we shouldn't be? Let's let Clippy show me. Can I get a console, please? Thank you. Thank you, VS Code. I'm so grateful you gave me a console. Yeah, I know we didn't construct those yet. Oops. We'll fix that. Wait a minute. It's stopping at that point? Oh, no, we need to do Clippy test, right? Tests. There we go. Here we go. Returns an async block that contains a reference to what? Oh, pings. Okay, so then I was planning to maybe make it a ref cell. I think I do need to do that after all. And also that needs to be mutable, right? Or it needed to be mutable if it was just a vector. Now it's not. It's going to be a ref cell. So we will get interior mutability here. So we'll say pings dot borrow mute and then push. Now the borrow checker is happy again. And then we can't do this without doing a borrow. I thought that would work, and it didn't. Do I need to borrow that one too? Can't compare a reference to a vector with a ref of a vector. Why not? Do I need to dereference after borrowing? Now what? Okay, getting close. So I don't need to borrow the left-hand side. Okay, and then this is just saying you shouldn't do that. I'm going to say thank you, but no thank. Sorry, but not sorry, Clippy. So, yeah. We're going to allow that here inside our tests. Yep. What's wrong with this? What? We can't do that? In the inner? Okay, we'll do it in the outer then. Right here. That's weird. I never ran into that before, that I couldn't apply an inner attribute. What was the error on that one? Why can't I do an inner attribute here? It's not permitted in this context. Inner attributes annotate the item enclosing them and are usually found at the beginning of source files. Outer attributes annotate the item... So what? It's saying that it's only allowed at the source file level? Huh. I thought you could do that inside a module. Oh, I guess I was wrong. I learned something new from Rust. The cliche is you learn something new every day. With Rust, I learn something new every 20 minutes. Okay, this is probably going to... Yeah, I'm not awaiting the overall for each, am I? Right. And then this no longer needs to be mutable because I'm actually not mutating it. For each does not mutate, right? It actually consumes the WebSocket. Ooh. I mean, that's okay as long as we don't use it outside the reader. Right? I'm surprised that it didn't tell me I had a borrow problem with that. I guess because it's owned by reader and we blocked on it once, so it's dropped after that. So we wouldn't be able to use the WebSocket after that. This would drop the WebSocket once it's done, and I guess that's okay. I think that's okay, but I'm not sure. But anyway, yeah. Because we consume it in the reader, it doesn't need to be mutable. Because for each consumes it. Okay. Just wondering if that's how we want to do it. If I do that, then I can't do that and then send at the same time without implementing the sync interface too. Is that what I need to do? Do I need to implement sync? Probably. I'll probably need to do that. So, talked about stream. The complement of stream is sync, right? And we can actually see that through... where is it? There was a way you could split them. Yes. Here. So one of the things that stream extensions gives you is you can split... What's the self in this case? Where are we? An extension for stream. You can take a stream and split it to give you a stream and a sync. If we implement sync, that lets you have different owners for the reader and the writer, which we're going to need, right? Because if I don't do that, then like I can't say do that and then, hey, let's also send a ping. It's going to complain to me, right? Where do we do that? Like right here, right? Pick an easier one, like hello. If I try to do that, it's going to say the WebSocket's been moved. See? Can't borrow, WebSocket is mutable. Oh, wait, that's a different error. Wait a minute, does that mean I can? No, borrow of moved value. Yeah, so I won't be able to write to the WebSocket if we just implement stream, because stream, when we consume the stream, it takes over the WebSocket. So I'll do that in a bit. Let's first get the stream working. So this doesn't need to be mutable for now. It's owned by the reader. I fix the other compiler errors I have. This is a problem because this is not public, right? These are warnings because we never actually use them. Okay. So then I can run this and see where the next thing I need to work on is. Unimplemented here in the back end. Okay. So then we need to put the data somewhere where we can get it on the read, I think, right? I think so. And I might need to read, I think what we're supposed to do is like tell the context that we want a waker and then stash that somewhere so that when we get to here we can call it. But fundamentally I want to have a vector, don't I? That we're going to push into here and pull out of here. Or I guess a channel. It doesn't really matter. Does it matter that much? Could I use a channel here? Channel. It'd be in features, right? an MPSC. How would I use such a thing? The receiver, for example. Sure. Could I call try next from poll read? Or yeah, poll read. Could I have poll read called try next? Because it would just tell me. Wait a minute. How does that work? Oh, without notifying a context if empty. I see. So if you wanted it, you would use stream instead. And that would be poll next. Okay, so maybe we could have poll read call poll next and pass along the context. Yes. Well, but then we'd have to map it, right? Because when we get back the vector, we'd have to write it to the buffer provided. Oh, and we might not be able to fill the buffer completely. Shoot. So I think it is better to have, we'll just keep it simple. Backend will have a, this I have to share, so it's, input is a arc mutex vector of vectors of bytes. 4. Is that enough greater than signs for you? Okay. That's in standard, right? Use standard. Sync arc, right? Sync arc. Actually, that has both arc and mutex in it, right? Yep. Aha. Formatted for me. Nice. All right. Oh, I never pushed out my Discord notification. I never hit enter on that. My bad. Sorry, I never... I had that post ready, but forgot to hit enter. All right, my bad. Some people rely on the Discord notifications to know when I go live, and I forgot to hit enter. Yeah, took me 97 minutes to realize that. Yeah, professional streamer here. So I need to provide that here, right? So, did I call it input? I did. Input is arc new, mutex new, vec new. All right. So this one would be self.input.lock.unwrap.push input. And then to do, need something here to wake up the wake up the waiters on poll read. And I think I'm gonna have to do some reading to figure this out. So here we would check it, right? We would say let input equals self dot in what? Do I have to like get it or something? As mute? Okay. Input. Well, how come I can't get to input? Let's maybe write what I wanted to write. Input.lock unwrap Why can't I do that? I need to get into the pin. I don't know how to use a pin. That's the problem. Let's learn how to use a pin. That'll consume the pin. How do I just get to it? I guess we'll just look at the examples. Hey there, Rally Monkey. Okay. Thanks for the cheer, Rally Monkey. See you later. See you, Jill Mega, also. So yeah, hello and goodbye, Rally Monkey, and hello, Nui. Raimu Games. I haven't used that account in a while. Do they have an example of how to just use it? Is this how you use it? As ref, as mute? Okay, so then I'm supposedly I can say as mute. Or as... Okay, it still won't let me do it. Why not? Oh, because I have this... Oh, it's the self itself. No. I don't get it. I called as mute. Didn't I get back the thing? Oh, that didn't do anything because I already had... No, it's a pin to its target. No, and how do I use this? It says I should be able to call a method. I don't know how to use pin. Maybe I need to hit the book again. They talked about pin. Pin. Don't they talk about pin in the book? Okay. Forget the book. Let's go to the reference manual. Pin. That just leads me back to there. Really? They have no more information about this? How about pinning? Is this it? No. Okay, I just don't know how to search. So I'm gonna go do a Bing search. Rust pin. Pinning. Oh, it's in the asynchronous book. Oh, okay. That explains it. And it's the part they've actually written in Rust docs at pin module level. Yeah, that's what I started at, and I couldn't figure it out. Oh, wait, you're right. You're right, Loke. Let me give you a point for that. Oh, that's the first point, so another point. You're right, they do say C pin module. All right. It's sometimes useful to have objects that are guaranteed not to move. At the high level, ensures the point E has a stable location in memory. Got that. By default, all types are movable. Got that. Okay. Pin wraps a pointer type, so pin box T functions much like a regular box T. When the pin box T gets dropped, so do its contents. The memory gets deallocated. Similarly, pin mutable reference T is a lot like a mutable reference to T. However, pin does not let clients actually obtain a box T or a mute pin to pin data, which implies that you cannot use operations such as mem swap. Okay, that makes sense. So it's like a guard against moving something. But how do I use it in place? That's what I want to know. And as such, it interacts with deref and deref mute. Do I just need to dereference it? Is that what it's trying to tell me? So I would just dereference that? Like that? Or that? No. That's not what it's telling me to do. Self-referential struct. I want to see where it's actually used. I don't see where it's actually used. I see where it's constructed. Oh, is this it? Get unchecked mute in unsafe. John, who has a video, it's not. I can't look at the whole video right now. That's the problem. I'm trying to. I'll watch that later. Maybe that'll supplement my learning. Thank you, Silmith. Maybe just read this. To pull features, they must be pinned. Why pinning? How it works. If self is a pinned, it does let me go to self state. So why can't I go to my input then? Oh, wait. I know what I did wrong. There is no input. I'm just dumb. The input is in the back end, not the front end. I need to share it between the two. This needs to be in both the back end and the front end. So, which means I need to construct it once and then clone the reference when I give it to both. So, let input equal that, and then we have input.clone, and then this can take the original. Input is input clone. All right. Now, both of them have a reference. That's why I used the mutex in the first place, and the arc and the mutex, right? Is because the lock prevents it from being accessed by two different threads simultaneously. The arc makes sure we can share it between the two. Now I should be able to access it from here. Yes. It's a mutex guard. Exactly. So I should be able to say that dot, right, if input dot is empty, then pending. Otherwise, it's ready. And I have to give an OK with a size. In this case, it's going to be the lesser of the two, right? So it'll be bytes red. So we'll have to figure that out. So here, let bytes red equal, is it standard? I forget where min is defined. Standard comp min. And I don't know if it's in the preload or not. We'll see in a second. So it's going to be the minimum of, so a buffer is given, right? Of buff.len and the front of the input. So let's say input at this point is borrow. Well, I can't do this. So let's say input front is borrow mutably the input first one. Actually, is there a method of vector I can do like first? First. And that gives me an option. Oh, okay, so I can actually do this differently. I can say if let sum input equal input front equal, actually, does this consume self? No, it just borrows it. So I can input these lines, else these that. So I don't need to do that. Front first. So then if I do mutable there, because first can give me a mutable reference, right? Oh, it doesn't. Well, that's not going to work. I need to mutate that first one, so I can't do it that way. Never mind. Go back. Unless there's a first mute I don't know about. Hey there, Pyro. How are you doing? I'm trying to figure out how to do the inner workings of asynchronous stuff in Rust. It's really scary. And I'm kind of stumbling through it. I had to read this stuff about pinning to understand that I was on the was on the wrong track with the problem. So I'm like, oh, okay. You can actually if you're given a pinned self, you can still access your own state. You don't have to do something like dereference or any crap like that. So I can still do that. The problem was input wasn't actually in my structure at all. It was in the other structure. So I'm just kind of stumbling along. But, you know, I'm happy. As long as during the stumbling process I'm learning stuff and I get stuff working. Yeah, so for example, if I need to get the first vector in the list of vectors, can I call first and be able to mutate it? I don't know. It's too many firsts. Well, let's just look at vec. I'm guessing first isn't part of vec, it's coming from a different trait. Yeah, what trait? Oh, actually, there it was. It is from deref. Oh, there is a first mute. Aha. Okay then. But yeah, I can do that. So redo and just say first mute. And I don't have to say that, do I? Because it's already a mutable reference. Yes. So then we can see what's smaller, the buffer we're given or the number of bytes we have left. Right? And then, how come I can't say that? Probably because this has a semicolon. And it has to be declared mutable. Fair enough. And then the whole thing can be reduced to what? A map or? Okay, fine. Input.first mute.map or. The default is pending. The F here is given an input front, we would do this junk. Okay, I've rewritten it. I don't know if that's easier to read though, especially with the formatting it did on me. But basically it's saying go to the input, take the first one, and then map it through a function if it is something. If it's not, then the task is pending. So there is something, then we're going to say we're ready and we've given you the bytes. So the number of bytes to give is the minimum of the number of bytes they asked for and the number of bytes we have. So once we know the bytes that are given, then I want to do a copy, right? Standard mem cop. Can I do a copy? Where's copy? Is it IO? Or pointer? It's pointer. No, that's unsafe. How do I do the Clippy opinions have official Rust status? I don't know what you mean by official Rust status, but what got me into using Clippy was that it is teaching me a lot about what seems to be more widely accepted in the community. I don't know if you call that official. So when I look into individual Clippy warnings, I see that they're always vetted by the community somehow through one of the Rust Lang GitHub issues, and sometimes it's backed by RFCs and stuff like that. So each one is at least like internally discussed and debated and all that stuff. And they do say in a few of them that it can be a little bit over opinionated. So if it gets in your way of improving your code's readability, you can go and disable them, which I've done, right? I've disabled the ones in my unit tests a lot of the time, like a string literal as bytes, so that I can do this. Because if I don't do that, the alternative is you had to make it a byte string, which won't work until I make not only a reference to it, but do a slice of it. And I think that just looks ugly. So I'd rather just say as bytes. So yeah, I'm pushing back on Clippy a little bit when I say that. I don't know if that's going against official Rust or not. But I'm pretty sure, but I'm led to believe probably it's fine because a Clippy is over opinionated, especially when you opt into pedantic, which I do at the library top level. I do that because that helps me learn a lot of things I don't know, like the fact that the stuff we were just doing. The fact that they recommend map or instead of an if let else. They say it reads better. I don't know if I agree, but I'm trying to go with the flow. And maybe just getting used to it. Maybe I will find it easier to read. I'm not like, there's no like initial urge to reject what Clippy says. If anything, it's like I'd like to learn more about why the people behind Clippy think that way. Okay, how do I copy stuff? Is it swap? I thought I could just, okay, that's file system copy. Intrinsics copy? That's unsafe. Isn't self input on mutex? It's an arc mutex, yeah. So that's why we have to lock it. And it'll stay locked for the whole poll, which is fine because we don't actually block here. We're either saying that we should yield, or we don't need to yield because we have we can proceed or not, right? So it's safe for me to hold this lock will hold a mutex guard. This will be a mutex guard around my vector of vectors. Okay, so how do I copy bytes from one vector to another safely? Seems to be applied by people as required style, which is a bit odd as it demands you change perfectly legal and readable code for implicit or overly terse constructions. Yeah, I like to think of it as that Rust tends to make overly opinionated guidelines. And that's one of the things that it's not my favorite feature of Rust. Like things like the opinionated naming convention, the terseness of names, that kind of thing. But you know, I'm not saying it's horrible. It's just something to get used to. It's part of the ambiance and the mood of the language that the community around Rust seems to want to be more strict in guidelines. I mean, there are pros to that, right? In any company where you have teams that have to work together, you hear about coding guidelines. It's not to make the employees suffer. It's to try to get some consistency. And people are going to have to bend. Not everyone's going to agree with styles. So you try to make a consensus that most people are happy with or can compromise for, and then you get kind of strict and opinionated about that. I have a feeling the strict guidelines is coming from the Rubyists. Who knows? Could be. But anti-Clippy always suggests you to change opt-map into opt-map or else. Yeah, because of the lazy evaluation. Yeah, I agree that the order is weird. I think Musen said the same thing, that it's weird to see the else first and then the if, right? This is the else technically, and then this is the if. I believe that is because of the fact that it flows better to have the longer item second, because you can a lot of the time stuff the value right in the front. Whereas if this were backwards, it would kind of be hard to see the trailer. You'd have to stuff it there, right? And then you might be confused seeing that, thinking it's part of this function. I can. Thing is, I don't know the real reasons why, but I can make guesses as to why things are ordered that way. I could be wrong. They could have just got it backwards because they were sadistic. I don't know. Let me look about in Rust how to copy bytes from one vec to another. What's the idiomatic way to copy clone a vector in a parameters function? Both unwrap or else and map or else take lazy closures. Yes, the or else, I've come to understand means the else is also a closure. But I think the or else and the or have the parameters ordered the same way, just to be consistent. The mappings are often longer. Might be, yeah, it could be. Where's the answer to this? Okay. Okay, that looks like it's a specific problem that I don't care about. That's a specific crate. I'm surprised that it hasn't been asked a lot. Maybe it was just here and I didn't see it. Copy a slice? That is clone. I mean, here's some. They only got 3 points, but I could do that where I iterate them mutably and do assignment of every byte. That seems awful, though, because that might not benefit from like multi-register move. Show us his Stack Overflow. That's not what I clicked. Can't show more. Oh, it's doing a Stack Overflow search. Wait, but it's only showing me one result? Oh no, it's showing me this one in Stack Overflow. I got it. I need to show more results here. Mem copy? Yeah, is there a mem copy in Interesting that they have a C. Copy non-overlapping? Is that what I want? That's also unsafe. I want the safe version if there is one. Maybe there is no safe version. Maybe I just end up doing a swap. I mean, a swap is fine for me. I know how to do a swap. So I would swap mutably buffer from 0 to bytes read with mutable input front 0 bytes read. Right? That'll that doesn't work. Probably because I forgot to mark something as mutable. Size of values of U8 cannot be known. Which one is it having trouble with? Buff or input front? Shouldn't it? Please have a look at your last message. Okay. Your last message was, you shouldn't you use try-lock because the mutex is already held, the thread will sleep until the mutex is released, so no other features could be processed. But I'm not blocking when I'm holding the mutex. None of this blocks, and I wasn't going to block here either. So the lock is just to prevent them from colliding. As long as neither locker awaits or sleeps, it should be fine. But you're right. If I was going to hold on to that guard and then do an await or a sleep or something, it would be a problem. Yeah, it's going to block until the thread releases it. So if we're going to push another thing into the vector, let's do it this way. If we were in the midst of pushing here, and then someone tries to pull the read, I do want it to wait a short amount of time for that, right? And if we were if we got the lock here and we were in the midst of copying something out, I think I would want this to wait. Copy from slice. Maybe that's the one I'm looking for. Let's see. So you might have something there, Loke. You might be onto something if you're saying that instead of actually blocking here, I should maybe be more asynchronous. The problem is this is a synchronous function, so I would have to make this asynchronous somehow in order to lock without blocking here. This one could be because we could just say it's pending until we get the input lock. If like we could do a try lock, and if we couldn't get it, we would be pending, and then we would set up a waker for when we can get the lock again. But I think that's so optimized that to be like, I don't really need that, especially because this is all for a test framework. This isn't going to go into the actual library code people will reuse. This is only for testing. But I don't want to discount what you're saying, because you have a point there that this will block, and this is an asynchronous semantic, right? So technically, this is kind of gross, and that really what I should do is try lock, and if that fails, I should return pending. I would do that, I think, if this wasn't in the test fixture only. But I guess I'm saying I'm allowing a little bit of flex. I'm allowing it to be a little bit dirty because it doesn't really matter because it's in the test. Spawn a thread maybe. Okay, I was going to look at this one. Copy from slice. Oh yeah, that's exactly what I want. Thank you, Captain Marchua. And that's 1 point. The first point, so I'm going to give you another one, and I should say hi as well, since I didn't say hi before. I didn't say hi to Silmith either. Let me catch up. When I get focused on a problem, I stop watching who's coming in new to chat. I didn't say hi to Pyro in chat, but I said hi out loud. I remember that. And then hi. Yeah, so we're good points about the mutex, but again, because this is all just for testing, it's in configuration test only. I'm being kind of loose and just going to use the mutex. All right, yeah, so I'm going to try to use this copy from slice instead of doing this swap. What was the problem with swap anyway? Why does it say the size of the type can't be known? I gave it specific sizes. Is it that I don't want this in front? No, that's not the reason. It wants a mutable reference. Then I don't really understand what I did wrong here with the swap. Size for values of type array of bytes cannot be known at compile time. I agree with that. The trait size is not implemented. Maybe it has to do with the bound on T. The bound on T is where? Interesting. It doesn't actually say what the T is. You notice that? There's no where T. Is it because it's an intrinsic? Sure, but this has a size. The size is bytes read. The size of this is also bytes read, right? Unless I'm not understanding something here. These sizes of these buffers should be bytes read. That number of bytes. So why does it say that the sizes cannot be known at compile time? Maybe I would see better if I did Clippy on the command line. Swap doesn't have a size known at compile time, required by that bound. I have a module name repetition. Oh. Okay. Yeah, I should probably just call it message, shouldn't I? Okay, maybe okay, well, I just want to get to the bottom of why I couldn't, because that mem swap should work, right? So I'd like to know what I did wrong. Oh, they have to be equal in size? Empty bound implies size. It's a bounded at. So, what if I did something like let LHS equal, which is a reference to something U8 of size. Can you do this? Can I do that? And then say this? No, because that's not known at compile time. That's the same problem, right? So swap doesn't work with slices, in other words. Swap is working with arrays. I think that's the whole point. The core of this is that swap doesn't work with slices, and that's probably why they have the copy from slice in slice, right? Yeah, I wonder if they say that somewhere. Like, you should use this instead of swap. I don't know. Anyway, we'll just use this one. So the way I would do that is buffer is already mutable, so we would say that slice is copy from slice the other one. And actually the other one doesn't need to be mutable because we're not swapping anymore. Okay, that worked. Instead of copy from slice, you could also use IO write and buff write. Oh, I forgot about that. You can do the writer into a buffer. Yeah. So I could do, you're right, Silmith. I could have done buff.write. If I pull in the write extensions, right? It's like standard IO write, and then well, I can just do that. And then, where was I? Here we were. Now I can call write, right? Okay, this returns the number of bytes written. Oh, will that'll handle the this minimum for me, won't it? Hi, Anakin Luke. So maybe write is better because it will return to me the number actually written, and it gives me an error when it couldn't write. So I can just unwrap it, correct? Wasn't it saying that bytes read is a runtime value? Yeah, that's why you can't make an array of bytes read size at compile time because it's not known until runtime. Yeah, I think who was it? Locke said before, Rust not knowing that two slices are equal in size is the problem. Even though I use the same variable in both places, it just didn't look deep enough. Rust by example book said it. Said that it doesn't know the length of an array at compile time. Yeah. Write all is better. But then write, that's if I use that. But if I use write and I don't do that, maybe write would let me do that. Let bytes read equal. And then I would write input front into it, right? Borrow that. Unwrap. Won't I get the number of bytes read out of that then? If buffer is mutable. Oh, wait a minute, it is mutable. Cannot borrow buffers. Oh, do I have to say mute here? That's odd. What if I just do a star in front? Okay, why not? Because it's a slice. Interesting. So I have to say mute twice. That's interesting. Attempt to write the... This function will attempt to write the... Actually, this won't work, right? Isn't this going to append to the end? Yeah, I should probably look... I want to look it up because I want to learn this better. If we look at U8... I thought I could look that up. Or I guess we can look at write. And we can see the implementers. There should be... oh, that's interesting. Implementers is empty for write. Wait a minute. Okay, here we go. Yeah, I bet you if we looked at this... Write is implemented by copying into the slice, overwriting, and say, actually, that's what we want. Note that writing updates the slice to point to the yet unwritten part. Okay, I didn't know about that. The slice will be empty when it's been completely overwritten. Actually, that would be handy because then we could put it into a loop. Write all will fail if it can't write the whole input. Yeah, I don't want it to fail. I just want it to tell me the number of bytes written. And this is actually a nice side effect that it will update the slice so that I can put this into a loop. If I put it into a loop, then I don't want to do a map or, do I? Yeah, let's put this back. If let some input. Well, it's going to be a loop. No, hold on. It should be if input dot is empty, pending. Else loop. Well, else while no, yeah, we can do it this way. While not buff is empty. I need that this one. I should turn it around and do it this way. I should just take off. No, I don't want to take it off of the input vector. Only when it's empty do I want to do that. So this makes more sense to me. That we would say if let sum input front equal input first mute. Yeah. Then bytes read is right into the buffer that, and then if bytes read is equal to input front dot. Actually, what does it do with the input? Can I look at the source for that? Oh, look at that. I can look at the source. What does it do with data? Oh, it's only borrowed it, so it can't change it. Yeah, so then we can change it. If bytes read is equal to input front length, then we want to do input dot. I need to pop the front. How do we do that? I forgot how to pop the front of a vector. Drain? I guess that's one way we can do it. Drain 0 to 1. Else input front dot drain 0 to bytes read. I think it's what I want, right? And then we need to have a total. Let total bytes read equal 0, and then add to that here. And I almost forgot the mute again. Bytes read. Total bytes read goes here. All right, how's that? How's that? What do you guys think about that? Buff binding should not need to be mutable, only the reference. You mean in the trait for write? Self is mutable because of the conventions like this, that it updates the slice to point to the yet unwritten part, which we're using to our advantage, right? So every time we do a write into the buffer, it advances the buffer so that we can write into it in the next loop, and we can also check if it's empty. So this conveniently allows me to not need to pre-compute the bytes read. It's going to try to write all of it, and if we give it more, it will empty out, and we'll get, basically we end up getting the minimum of the size of the input front and the buffer, right? And if we consume, if the buffer was smaller, then we'll end up just draining some of the input front, and then it'll be empty and we'll be done. But if the input front is smaller, then we'll pick it off of the input and then loop again and pick a new front. There's got to be a better way other than draining 0 to 1. Someone's got to have invented a different way to do that. Rust, vec, pop, front. Really? Oh, here we go. Idiomatic way to remove the first element out of a vec. What's the answer? You doubt that there is one. Remove 0. So I could have said remove 0. Oh, yeah, there, that works. That's maybe more idiomatic. Yeah, instead of using a vector, I could use a DQ, but I'm just being lazy. It effectively takes a mutable reference to a slice. Yes. Yeah, and it's updating the reference to the reference to move it, push it forward. Mm-hmm. Yep. The only other way to do it would be to return self somehow. Being lazy, every developer ever. Yeah, exactly. Yeah, so I'm totally being lazy with my input, right? This is a vector instead of a queue, a proper queue. So we're pushing onto the end, but we're pulling out of the front, which is going to be a little bit expensive to do this remove. And it's like, it's only going to be done by the tester anyway, so I'm not going to care. Although maybe a good exercise would be to use a real queue. That way the pop front would exist and would be more efficient. So I'm not even going to add anything here. But I think this ought to work, right? I do need to figure out how to, when we are pending, how do we wake it up later? You should use a vec_dq in that case. Yeah, maybe I should learn how to. Let me make a note. Homework. Learn vec_dq. We'll make that homework for myself. See, I have homework too. Okay. I have homework too. I gotta, she stuck her tongue out at me. See, now that my kids are like in school virtually half the time, I can turn my head and talk to them when they're in class and then talk smack and all that stuff. Basically the same as Vec, but lets you pop from both sides. Yeah, that's what I sort of want. But I don't want to get my brain too full right now. Okay, we need to mark this, right? To do. Need some way of setting up the caller to be notified when we're ready. So this will complement the other to-do up here, which is need something here to wake up the waiters. And I think I need to learn about how the waiter stuff works in futures first. It doesn't allow you to slice inside since the elements might not be contiguous. That's fine. I'm not slicing inside at that level because it's a vector of vectors, and I'm only slicing. Well, I'm slicing that up. Well, I'm copying out of that, but I'm doing that with a drain there. That's the other inefficiency here, right? Is that I am slicing up the inner vectors by using drain, which is going to end up copying the remainder up to the front. And but I don't know any alternative to that, unless we use some kind of advanced data structure like a circular buffer, a ring buffer, and then every time we do a write, well, we might only copy up to the end of the ring buffer and then have to loop back and read from the front of the ring buffer the second time. All right, anyway, I think it's time for me to learn what to do when it's pending, and I think I need to go back to the book for this. The book. Futures trait. Okay. It is the center of asynchronous programming in Rust. Futures can be advanced by calling the poll function, which will drive the future as far towards completion as possible. As it completes, it returns poll ready with the result. Future is not able to complete it, it returns poll pending and arranges for the wake function to be called when the future is ready to make more progress. So this is the part I need, right? When wake is called, the executor driving the future will call poll again. Without wake, it'd have no way of knowing when a particular future can make progress and would have to constantly poll. With wake, the executor knows exactly when the futures are ready to be polled again. Buff write input already written and keep already written equal to the number of bytes drained. I'd have to store that though, right? Because it might completely fall out of the poll read with it not completely drained, and we might never call this. So I'd have to put the already written somewhere, right? Maybe alongside the input. Inside of this vector. Actually, it doesn't even need to be inside of this mutex. I mean, it could be alongside, like, you mean like this, already written. U size, right? I could do that. And then already written would be what we use when we slice this internal vector. Yeah. Let me again, I'm gonna take the license to be lazy since we're doing this only in the test configuration. But let me give you a point for that, because that's a smart idea. That's what I would do if I cared about the performance of this work. It would make it a little bit more hassle because I'd have to maintain it and I'd have to have used it here, right? Everyone is hosting me. Everybody who can ought to start spamming this emote because it's inspired by the fine gentleman who is now hosting us. How is your COD? Did you kill a lot of plebs, EJ? Hey there, Pro Table Flipper was already here. Hey, EJ. Killed a lot of plebs. Great. I watched about 10 minutes of it. And then I'm like, I've already been planning to stream, and now this is just delaying my stream start. As much as I'd like to watch EJ, I really need to start my stream. So sorry I couldn't watch all the way through. I'm doing some painful learning here. How do we do asynchronous reading using signaling when we're not ready and when we're ready? And I'm reading about the part where how do we set up to, when we're not ready, how do we set up to notify the system when we are ready so it can re-enter the poll? And I'm reading the book. If you would like to follow along, there's the reference. El Resfriado de la Grita. Hello. And the Geek Pirate. I didn't say hello to the Geek Pirate. I missed that. I'm sorry. That was before the raid happened. Hey there, Geek Pirate. All right, so I'm reading about how do we wake up the executor. Such a cool word, executor. Or you might say executor. I think executor sounds nicer. So consider the case where we want to read from a socket that may or may not have data already available. It's actually very similar to what we're implementing right now, right? If there is data, we can read it and return ready, which is what I just did before EJ came. We already did that. Like it that way too. Cool. But if no data is ready, our future is blocked and can no longer make progress. When no data is available, we must register wake to be called when the data becomes ready on the socket, which will tell the executor that our future is ready to make progress. So this is what I need to learn how to do. Okay, so we need to take wake, which we get somehow, and stash it so that we can call it later. This model of future allows for composing together multiple operations, etc., etc. It's all good. We can run them simultaneously. What's this first take? Oh, that's similar to what I was doing, right? Oh no, it's because it's an option. Okay, never mind. Blah, blah, blah. So here we go. Task wake-ups with waker. This is what I need to learn. So I'm not giving an waker, I'm given a context. So I'm scared that they don't use the same words here. Should I be scared, or is a waker wrapped into this concept of a context? I think they're building us up conceptually one piece at a time here, right? Oh, no, here we go. Here's a context, and you get a waker from it. All right, so where do they introduce context? I didn't see where they introduced the word context. They never actually say it. They just showed it in the code. That's weird. Why don't they ever explain that? I guess you're supposed to read the code. So they don't say how to get a waker, but they show it here. All right, so that's how we'd hold on to it then. We have an option waker, and then we get it from the context. Okay, I think I understand. So we need to do the same thing. Context is just a wrapper over waker so that hypothetically some runtimes could put there more stuff. Oh, Good to know. Thank you, Selma. Now it's just a wrapper of waker. Good. All right, so then we would hold on to it here, right? Input waker is an optional waker. And that comes from futures, I hope. Futures waker. It does not. Okay, what's the actual type? I guess we'll know. No, it's waker. Task waker from standard library. Interesting. So it's not in futures at all. So it's in task waker. Alrighty. So we have waker. So we need to initialize it to none because no one tried to ask us for data yet, right? And we would set it when we are not ready yet. So that is the to-do here. So it would be self.inputWaker equals context waker and sum, right? And I can't do that. Oh. Wait, I have to get a reference to a waker gives me a reference? Ew. That's not what they did here. Oh, they cloned it. You can clone the waker. Let's do it. Let's clone that waker. And then, don't tell me I need to do that, right? No? Oh, it's replace. Keep forgetting that. Lots of these concepts I just don't like, and I don't need to say some. I just don't get the concept sometimes. And this needs to be mutable. No. Oh, I'm borrowing it immutably oh, for that. Oh, crap. Oh, well. Yeah. Actually, why can't I do that? Why can't I call... I don't need to borrow it as mutable. It already is immutable. So do I need to do a as mute or something? EJ just subscribed. Got Adol to open that chest and find the book of the EJ subscribing to us. Thank you for the sub, my friend. You're stuck in JS land for life, huh? All right, we'll figure this out. I'm wondering if it has to do with this as mute thing. This is a generic method to go from mutable reference to a pin of a mutable reference. And actually, we already have a pin of a mutable reference. So is it like is it deref or something? I don't know what I'm doing. Do I need to do something strange like this? Grrr. Waker is just a wrapper of raw waker, which is a pair of constant pointers in a vtable. Okay. Don't suppose, Silmith, you happen to know how I put the waker into my option, because it won't let me go through my own self pointer. Does it have to do with the fact that I am holding this lock, which is a borrow? This is going to borrow from self, right? It's borrowing immutably from self. Do I need to like take the lock out and then lock it? I can't do that, can I? I guess I could clone the lock. The lock is inside an arc, so we could clone it first, I guess. All right, that's what I'm going to do. So get input lock equals, well, I can just say clone lock and then lock the clone. Why can't we clone it? Because it's dropped while borrowed. Oh, that's right. So let input lock, well, let's use a different word here. Mutex self.input.clone. And then lock that one. Wait, how am I still borrowing it? Oh, mutable. There we go. Okay, that's a little odd that I have to do that. because this borrows self to do that. Just get the waker before locking. It seems wrong to get the waker and replace it before we even see if we're going to be pending it, right? It seems like I want to check first, is it empty? And then if so, we're going to put our waker in there. Also, this is if I don't hold the mutex while I'm doing this stuff, it'll erase this other guy up here, right? Who's going to be who's going to be checking the waker and calling it, I think. Yeah, I think this needs to be protected. This whole thing needs to be protected by that mutex. So I think the only way for this to work would be to get a reference to the mutex and then lock that. And then while holding the lock, we can borrow self for other reasons. I think that's the only way I can do it, right? The async await post of writing an OS and Rust blog nicely goes into the inner workings of wakers. Ooh, that's point worthy for sure. Because that sounds like some fun reading from me. Thank you, Silmuth. Check the compiler error. Bet it says borrows is for the entire if expression. Yeah, I think you're right, Sarian. Well, oh, you're saying this borrow. Yeah, let's do that. So let me put it back to self.input.clone quickly. And we'll look at this error in more detail. Okay. This is a mutable borrow. But while we're holding that mutex, we're immutably borrowing from self. So if I don't clone the lock reference, then what we're ending up doing is we're saying that we're only going to borrow it immutably, the entire self, not just the lock, not just self input, but the entire self. Yeah, so that's right. My misunderstanding was I thought this line would borrow this immutably, but really it borrows the entire self immutably. So when we try to borrow the entire self mutably to do that, we have something that you're not allowed to do. So my solution is to borrow self immutably only long enough to make a clone of the reference to the lock. We're not making a new lock. We're just cloning the arc part, right? Cloning the reference count. And then it releases the borrowed of the self and lets us borrow self here immutably later, or mutably later. What if you take the input self input waker before the borrow, then update that taken option, then after if replace self input waker again? In order to take it, well, if I take it, won't I have a problem with this other thread? We have to assume the worst and that this is running on a different thread, right? I haven't written the code here, but what we need to do is, after we push into the input, we need to see, well, is there only one thing? Actually, we should have checked to see if it's empty at the front. If it's empty, we're going to push into it and then... Actually, no, that's not true. We should take the waker out at this point and call it, right? And maybe it's okay then, because if we're in a race and we take the waker out before we lock, well, we have to lock to take the waker out, right? No, we don't, because the waker is not protected by the mutex. So yeah, I could take the waker. Actually, isn't that a problem? Shouldn't the waker be inside the mutex too? The way this works is how? Oh, yeah, it does, because back end is a different value. Yeah, we need to move the waker into that. Yeah. Or protected by another arc mutex, right? Let's just say we have a struct shared. And struct shared has the input. and it has the waker. And this is just a vector. And then this is a waker option, right? And then this is shared. Arc mutex shared. Right. Because we need one of these to be in the front end here. So then this turns into let shared equal arc mutex new shared. Input is a vector new. And input waker is none. Oh, I hate how it's... Does that fix... Yeah, good thing it fixes the formatting for me. Did I not call it input waker? I call it waker. Input waker. All right. And so then this becomes shared clone. And this is just shared. Oops. Right. And then here it's shared clone. Now we have access to the so this is shared. Yeah, why don't I just do that? So I separated shared out. What else is there? Just the sender. Actually, this is going to avoid the problem entirely because we lock the whole thing at once, right? Yeah, I think I avoid the problem with the borrow, so I don't need to do this clone. I just need to do self-shared lock. Yeah, and then do if shared input is empty. Yeah, I think this avoids the issue. The issue about borrowing sort of indicated that I needed to keep them together inside of the mutex, right? So this should be a shared input waker. Yeah, so it doesn't have the problem anymore. And the same thing down here. This is shared input. Shared input. Yeah, there we go. Fixed it. It's fixed. Yeah, so the whole problem that I ran into was I didn't couple these two together inside the shared context, which is protected by the mutex. Okay, and this is the problem here because it should be shared. And we need to do let shared equal that because we're going to say share dot input push input. I don't like the name being the same, so let me change it. Data. And this needs to be mutable, right? Right, and then we're going to say if let sum waker equal shared dot input waker dot take, then waker, just call it, right? You can't just call it. How do you call the waker? Is there a method? Call? No. Should just look at the book, shouldn't I? How do we call that waker? Wake. Should have known. Stream is still here. Hi, 715209. Were you gone for a while? The stream didn't go anywhere. We're 2 hours 43 minutes in. When was your last message? Were you gone for a while? An hour and 28 minutes ago. You left when I was implementing stream. Oh yeah, I'm nearing the end of that. So the stream implementation is oh wait, no. Where was that again? I'm confused. Hold on. Let me get my bearings again. Yeah. Okay. So I said I would do that later, and I was doing the test for it first. So test first. I needed to improve. Okay, going from one place to another. First, I'm like, we need to implement Stream for WebSocket, but that is needed by the test. The test was down at the bottom of here, right? So if as long as it implements Stream, we have this. But then the next compiler error was there was no WebSocket input. And the WebSocket input I had to do here, so I started filling that in, and I'm like, oh, okay. We need to somehow wake up the other end, the front end of the mock whenever we push data in. So that's what I've been working on for the last hour. So I had to go back and learn how to do wake-ups for futures. So looking at the book, we implemented that. And it took me a while because also because I forgot to couple the actual data being exchanged between the front and back end with the waker. I had the input outside, or the input inside of the mutex, but the waker outside, and that was causing borrow problems. It took me a while to realize that we want to borrow them together when we lock the mutex. So that makes it a lot cleaner now. We get access to the shared thing by locking it, and then we put the data in, and if there's something to wake up, we wake it up. On the other end, we is that, yeah, it doesn't need to be mutable, yeah. On the other end, we also do the lock, and if there's no data, I don't need this to do anymore, because what we do is we get a waker, clone it, and put it in to our shared state, and then return it that it's pending. If they poll us and there is data, then we do the copying. So you missed me implementing this copy, but basically I have a vector of buffers. So we're employing the write function from where is this in? I think this is declared in standard IO write. Yeah, standard IO write trait. We pulled that in so that we can write into a buffer, which has a really cool side effect that I learned about. Do I have that on that? Yeah. So if you use the implementation of write for a mutable slice of an array of bytes, it updates the slice to point to the get unwritten part, and it I think where is it? Yeah, the write also returns the number written. So it made it really convenient to write this loop. We can say, hey, write into the buffer the next piece of data we have, and then we get back the number of bytes read, and it automatically advances the buff. All I need to do is count the number of bytes read, and then remove it from the from our queue. And I'm being lazy right now. The queue is just a vector, so I just do an expensive remove 0 if we consume a buffer. And if we haven't consumed a buffer, we do another expensive move of the leftovers to drain out the front of the vector. And then this goes in a loop because they might, in one poll read, end up draining our entire queue of multiple buffers. It's possible, right? So, and eventually we say, hey, it was ready, and we gave you that many bytes. So I think this is done now. It's ready to go, right? Did I forget to do anything? Should look at the warnings to see if I forgot to do something. This is just going to say what? That, okay, yeah, WebSocket message could just be message, right? Yeah, just call it message. Let message ping. Okay, never implemented that. So that's probably the next point where we're going to get a panic because that's not implemented yet. But I know how to implement that now. Yay! So we should just try it then, right? Well, we should hit that unimplemented part. Not implemented. Right where I thought it would be. Perfect. I like it when things work out that way. Is that vectoring? Yeah, it is. It just copies from the undrained part to the front. Actually, I should take a few minutes break. I need to go take care of something in the house, but it should only be a few minutes. So let me set a timer for like 3 minutes and I'll be right back. So not too long. I'll be right back. Okay, it wasn't even 3 minutes. More like 2 minutes. All right. I need to implement poll next. So, stream interface for WebSocket. Now that I know how to do wakers with the context, this shouldn't be a big deal, right? I know I'm going to need to hold on to a waker somewhere. Or, you know what we can do? We can send wakers down the channel. I would need a channel in the opposite direction, right? Let me think about this. No, I need a waker to go back into the WebSocket, don't I? Didn't realize drain consumed when it was dropped. Yeah. It's sort of a tricky function. I'm not sure where to put the waker. We need to get it at this point. Okay, so it really, we do need to put it here, right? Let's put it here for now. So, message waker is an optional, an arc mutex optional waker. And waker we know is, and we need arc and mutex and waker because we can't assume thread context here. So arc is in sync along with mutex, right? And then I think waker is in standard also under task, right? Yes. All right, cool. So it starts out at none. I wish this would sort by alphabetically, but it's not going to, is it? Ah. There we go. Put it first. And this should be an arc new mutex new none. All right. So I actually need to give a clone to that to the executor, don't I? So actually I should take this out and put it here. Let's give it a name. Let's give it a comment too. Message waker. Make storage for a waker used to Actually, it's got to be more than a waker. It's got to also have our queue. And this one I want to do correctly, like, right? So I think I do want to learn the vec queue. Make storage for a queue with waker used to deliver messages back to the user. This is received messages, right? Okay, so then this would be called what? Received. What's a good name for this? Received messages. Just received messages, and then there's a queue and a waker inside? Sure. So, received messages. Queue is vec dq new. And where is that type? It's in standard collections. Nifty. Collections vec dq. And then waker is none. All right, so then I need to define this type. Where to put it? Up here, I guess. So struct receive messages. There is a sorry, my brain not completely working right at the second. Queue is a vec a dq of messages, and then the waker is an optional waker, right? Okay, that should work, right? So then this becomes some received messages is a receive messages arcmutex. Right, and then oh, thank you for that follow, I appreciate it. Receive messages gets receive messages clone the reference, and we're gonna give the other one. I can't clone that one. Oh, it's because I want to pass it to this guy. Right, so the worker also gets one. Let's go to the worker. He also gets one. All right, and then the way I want to use it is provide it to handle message. Oh wait, no, I don't want to do this. Yeah, we need to leave this to do. Handle message is taking a worker message and dealing with it. So that's the transmit path. I need this to run in parallel with the receiver path, which I haven't set up yet. So, yeah. We'll do that in a sec. Right now it'll be unused. I just want to fill in this part right here. So it would be let receive messages equals self.receive_messages.lock .unwrap. And here I don't want to be sloppy about it. I should do expect. And or should I do a try lock? I should probably do a try lock if I can. If the lock cannot be acquired at a time, then an error is returned. I don't want to get an error. I'd rather get something that is asynchronous. I guess what I want is an asynchronous mutex, right? Maybe for now I'll just live with a normal mutex and put a note here. Look into using an asynchronous mutex to avoid blocking it all. Even for the received messages. Access to the received messages. All right, so the expectation, if we can't lock it, is the last holder of the received messages panicked. Save. There we go. Don't think there's an async mutex in Futures. I know there's not, but Musen told me about that there is one in async mutex, I think. Yeah, this one. There's a asynchronous mutual exclusion lock. So its lock actually gives you a mutex guard, which is a future. So you do a lock await at that point. Don't tell me how it works. I should rephrase that. I don't yet know how it works, but I assume the way it works is instead of blocking, this would yield until you can get the mutex, and then so would the other guy, right? The other guy also trying to get the lock would also have to yield while they're waiting, so you wouldn't have any thread blockage. Async standard also has one, but I think what he told it to me, async standard pulls in things from other crates. So, for example, the TCP stream that I'm using right now, technically it's an async net, right? If you go to async net and look for TCP stream, it's here. And I believe this is what is kind of, I don't know what the right word is, hoisted or inherited by. Async standard pulls in both of them. I think we could probably see it in the, yeah, check it out. It's in the dependency. So the async standard pulls in async mutex and probably also pulls in async net. I don't see it though. Oh, right. That's right. Async IO pulls in async net, I believe. No, that's not right either. No, yeah, here it is. That's for development only. So how do we get async net from async standard? It's probably buried in the dependency tree somewhere. Yeah, they're re-exported. So we can see async mutex right here. And now, just out of curiosity, I wonder how async standard gets async net. Is it through async IO? And how would we find that out? Well, if we know that async standard gets mutex from async mutex, would we be able to see that maybe through the source? This looks to me like it actually defines it in their... Oh no, it goes to async mutex. Okay, so then if I go to TCP stream and follow the source, would we see what crate that's in? So, source. Oh, that's actually in async standard. Oh, but it's it's the inner is a async of TCP. Okay, so it's not exactly the same, is it? This is an async wrapper around TCP stream, but async net has a TCP stream directly. Why don't you use that crate yet? Because I'm lazy. I haven't gotten to it. It's on my list of things to do to, instead of pulling in all the baggage of async standard in my dependencies. Remember, right now it's only dev dependencies only, but one of my other crates was, I think it was the server. Yeah, my server depends. One of the things to do is to decompose this into what parts of async stuff I actually need. Probably just async net and async timers. And then toss the rest of async standard because I don't need it. But then there's also the possibility that I drop it entirely and make it dependency injected because someone might want to use Tokyo instead. So Tokyo has its own versions of everything, right? Anyway, I need to change this, right? Because we receive the message and then we need to do something with it. We need to say if received messages dot queue dot is empty, then it is standard task poll pending. Otherwise, it's going to eventually be standard task poll ready. And we need to give a message. So that right now it's always going to be some message, although we'll have to handle the eventual case where we get a close, which means that should be the last message, right? So right now it's going to be some message. And we have to get the message out. So that would be let message equal received messages dot. How do we get it out? Oh, q dot pop front. There we go. And then why doesn't it let me do that? Oh, ready doesn't take an option? Hold on. That should be an option. Oh, is the item an option? No, the item's a message. So wait, how come I don't have to say some? Why is it letting me? Oh, because pop front returns an option for us. Yeah. So there we go. Remove the semicolon. All right. Yeah, async mutex might be runtime independent, so it makes sense to use independent crate for it. The only async mutex I know about, though, is in async mutex, which is its own crate, right? So that's not exactly independent. Like, I bet there's a Tokyo equivalent of this, right? This is tied in with async standard, right? Actually, I'm not sure. Oh, the dog's gonna bark because someone's coming home from school. Actually, this is dependent dev on both. Does that mean this is independent? Sorry for the dog barking. Should I mute for a while? Yeah, you both heard and now you saw pictures of my dog. No, async mutex is independent. You should be able to use it in Tokyo. Oh, that's neat. Tokyo has its own mutex. There's nothing runtime specific in a mutex. See, I wouldn't know that from the surface. There's nothing here that says, this is independent of runtime. They should have that as a banner. Independent of runtime. Certified. Independent of runtime. Alright, so... this probably needs to be mute, right? No. This needs to be mute. And I messed that one up. There we go. So this handles the problem of ready, but the problem of polling, I need to get a waker and store it, right? Receive messages dot waker dot replace cx dot waker dot clone. There we go. So if the queue is empty, we get a waker and store it, and we say it's pending. Then if we're not empty, we get the one from the front, and that's what we produce. So now that's just, I need to wake the waker when we produce something. So that's what that's the last part of this, right? It's going to be a little complicated because right now the worker thread only does the transmit path. We need to do the receive path too. Wish async crates better documented if they are runtime specific or not, and if so, which runtimes they work with. Yeah, me too. Dependencies have small token, yeah, but those are the dev dependencies, right? So these are all dev dependencies. So I'm guessing they want to make sure it works in both runtimes, and these are, you know, for their other testing. The only thing they're directly dependent on is this other guy, who it only depends on wakers and futures and waker function, which has no runtime dependencies. Convert closures into wakers. This sounds neat. Huh. The sleeper has awakened. They should make a Dune joke out of that. Okay, I need to split this connection, I think, because this is the sender part. I need a receiver part. Oh, there's a kitty. I am being handed a cat. Would you guys like to see my kitty? He's not at all happy that I'm holding him like this, but say hi. He doesn't know to look into the camera, because, you know, cats don't like look into cameras, but you get the idea. I'm sure he loved me taking him and holding him up like that. Yeah, so this is handling the transmit path, also the exit as well, because handles exit. Actually, it seems async mutex changed name to async lock, and it's newer. Really? So the other one was old? Let me give you a point for that, because they didn't say so in this one, did they? Shouldn't they release an update that says this is obsolete, look at the other... Maybe in their GitHub they said so. Huh, no, they didn't. And it was updated less than a month ago. Are you sure? Lock? It's got a lot fewer downloads. This looks exactly the same, doesn't it? Doesn't that look exactly the same as Async Mutex? The GitHub had a new name. Is it just is it a different developer? Or did is it the same one? They just changed the name? Why would they do that? Oh, you're right. They both map to the same GitHub repo, but they're different crates. So he used the same GitHub, but he just changed the name he was publishing under? Oh, wow. Okay, then. That's good to know. If I was him, if I was the maintainer, I would have published one last crate to Async Mutex saying that you should probably look at Async lock. But it's recently released. Then why does it have two names? September 22nd, but a different version number. That's weird. Oh, you're right. It doesn't depend on runtimes for testing. But then why would... Is that because... Oh, does the GitHub have both crates in it? Or did they change the name at some point? Let's see. Okay, maybe look at the history of this. I can't find my way around history in GitHub that easily. It's like, when we're looking at the file, there's a button to see the history. Where was it? Is it under the ... No. Do I do latest commit and then I see it? Ah. But then how do I see all commits for this file? GitHub's kind of frustrating. It literally says history right there. What am I not seeing? I'm just blind. I'm sorry, I'm blind. It says history somewhere. Let me look more carefully. Oh, history. Thank you. I'm just blind. So I'm guessing at some point you just changed the name. Well, wait. I don't see any mention. Implement using async mutex? What? Oh, wacky. Async lock dependent on async mutex at some point? What the heck? I don't get it. Okay, so I'm confused. So at some point it transitioned from one name to another and they built and one depended on the other for a while? Merge crates into a single repo. Okay, so we had two crates at one point? No, it's still dependent on one crate's still dependent on the other. So at what point did he separate them? Merge all crates? Okay. This might be it, right? The merge all crates commit. I don't understand the organization then. Check the blame. That's okay. I'm getting kind of... My brain's about to explode on that one. We'll just remember that, like what you said, that async lock is what I want. And through some strange sequence of changes, both crates exist, but they route to the same repo, which names it async lock. Who knows why? Anyway, back to my code. I think the first thing is to split it. So let's do that. Split the connection into its reader and writer halves. I think it's, I can't remember. Let's just guess. So can reader writer equal connection dot split. And oh shoot. Am I thinking of the wrong mechanism? Is there no way for a TCP stream to split it? I need to look at this then from the perspective of here. From a TCP stream, can I split it? Fundamentally, it implements async read and write. Can you, do one of these traits allow me to split? Poll read. Actually, I don't know if I'm going to be able to do this then. It's stream that can be split. How do you split a reader from a writer? Or can you? I guess I'm going back to the drawing board with search. Okay, we're done with all these. I'll leave that one open. Rust TCP stream split reader writer. Okay, this is the Tokyo documentation. And they have a split. Okay, am I just screwed if I use async net then? Maybe I need to switch to Tokyo. I feel like I've been here before. How do you split a TCP stream across two threads with async? This is with Tokyo. The answer is going to be called split. Yeah. So how do you do it with async net? Maybe the answer is you can't. Async standard. Okay, this is a standard net. Yeah, let's see what they say. Buff stream. What's buff stream? That's a stream. Hold on, maybe someone in chat just told me. Should be able to split it? Yeah, Tokyo you can. Maybe start a new crate that at first just re-exported the second one. Oh, I see. A re-export and then later replaced it. Okay. Okay, well this was that's buff read. Okay. Anyway, that's old documentation. Maybe I just look more closely here. Oh, maybe I just need to clone it and I get another handle to the same socket. Maybe that's the trick. I clone it. Give one to the reader and the other one to as the writer. Because I know at the lower level that at the socket layer you can read and write simultaneously. So yeah, I think this is the async net solution, is to do a clone. Let me make sure I'm looking at the right crate though, because technically I'm not using async net right now. I'm using async standard. API reference, TCP stream. What do they say about cloning it? Okay, it's different. Does it implement clone though? It does. Well, if they implement clone, then maybe they just forgot to document it here. We'll just try it out. Yeah, if it implements clone, it should work, right? Sure, clone. And then that's the reader. Let the writer be the connection. Oh, yeah. I need to take it out of the box first, right? Oh, it's a dying connection. Oh, that's a problem. We might have to clone it earlier. When we know the type. Oh, I could just specify that it has to implement clone. That should work, right? Connection has to be clone on both. Sure. Now what? It requires sized. Really? Does clone requires a clone requires sized? Shoot. So I can't do that. Good night, Nui. Can't dying clone. Yeah, we'll have to clone it before we package it up. Then, yeah, it's not too bad. So that just means I had to give both of them in. So I have to have the connection TX, connection RX, I guess. And we'll use the TX for now. Hold message. This one gets just the transmitter. Send frame gets the trans. I'm just trying to keep the names consistent here. So it's only used way down here. Okay, and then here where we need to give them both, it needs to be sent in to the socket both directions because we still don't know the types. So it's going to percolate around, right? Yeah. Async mutex semaphores that are separate crates living in the lock repository, and these were separate crates published. Async lock crate re-exported all of them. Later, they got rid of the small crates and merged into the single async lock. Okay. Well, the name makes better sense to me. It was weird when I first looked at async mutex and saw that it has a mutex, but it's got some other things. I'm like, it's more than its namesake. Yeah. It makes sense to me. Okay, so just doing the compiler-driven development now. Yeah, so wherever we do this, I need to clone it, and we can clone our own connection. I can just make the type clonable. How would I do that? We can clone it. Who uses the sender? The writer end uses the sender. The reader end does not. Yes, so... hold on. Yeah, so that means that... okay, so I don't want to clone it then. I think I need to have reader and writer aspects of this. Well, actually that's not that hard because we just have, we split it into two types. Yeah, it's just two different connections, so two structures. Let's do the split. So mock connection TX and RX. All right, and then the TX. So we'll just duplicate it for now and just delete the stuff that we don't need later. All right, and then the receiver has read, and the transmit has write. Oh, you know what that means is I'm going to want to split the read and write here. Yeah, so let's make connection TX and RX. RX. So transmit doesn't need to support read, and receive does not need to support write. Okay, we split it. Write for transmit, read for receive. What don't we need? Why is it complaining about both of these now? Oh. Yeah, mock connection. So we can just call it TXRX then. All right, fine. I don't care. Let's just call it by the short name, TXRX. All right. Shouldn't it warn me about unused things? So where is the backend? Oh, okay. The backend is not needed everywhere, right? I'm surprised that this didn't tell me that I didn't need it. RX is simpler, right? It's just read, and we only use shared, and we don't use the back end. Or do I? No, we still use the back end. Use the back end for both. So that means I need two back ends. Yeah, we need to split that up. So this is back end TX and RX. RX. So let's just do the transmit side only. Transmit side, we provide the... It's transmitting, so we get the output, so there's no input. So when we receive, we're providing the input for the WebSocket only. Yes, okay. So then this should be backend TX. I should prune out the things we don't need here. I don't think shared is needed for backend TX. Yeah, that's only the input. So we don't have that. So that's only RX then. So the transmit is just what? Just the receiver only, right? That means that the receiver doesn't have a receiver. The RX doesn't have a receiver. Okay, so then RX has the shared state only, which means I could probably collapse that, right? I could collapse back in to not have the shared at all. Oh no, I still want it for its method, for its... Yeah, I still need that. Okay, so then this is shared. TX shared, RX, and there is no shared here, and this doesn't have a sender. Okay, and then TX doesn't have a shared. Let's just sender and receiver there. And then RX, back in RX, shared RX, doesn't have a sender and receiver. It just has the shared part. Okay. Splitting it right down the middle. I think I finished it there. Now it's divided. Now I gotta go through all the code that actually uses this. So builders first, I guess. Use mock connection TX and RX, right? And that means I need to make them public. I guess I forgot to do that. Oh, it's not at this level. They're public here, but they're not used here. They're used. Oh, wait. No, they are. It's declared. Hold on. What is this telling me? Unresolved import. It should be, though. Is this not built right? Oh, it removed the names part, so it's just mock connection TXRX. So I should probably just make it use mock connection and then do mock connection txrx for these. So actually a lot of these are going to change. Let's search replace all of these lines to be let's do that again. All of these lines, copy, paste. Nope, that's not right either. All of those lines. Enter, paste. Okay, and then up one row back, mock connection tx. Oh, right, and then this new gives me. Okay, I get it back in for both. Okay, so then these tx back in tx, and these rx back in rx connection rx. All right. So then all of these have to change too. To be box new connection tx, box new connection rx. All right, getting there. Okay, this needs to be fixed to be snake case. What's next? Okay, now scrolling down. Okay, so these have to be fixed now. There's only 2 of these, so I don't need to do a search replace on this. I'll just do it twice. Actually, why not do them both at the same time? Yeah. Connection tx rx back and r. I can't spell. I can't use my keyboard. Mock connection tx new. I wonder if I should simplify this to like have a single constructor give us a double-ended connection. I'm going to find that I'm going to remove a lot of these though, right? Because I only use one direction and not the other. Oh, but I need to give at least the front end to the front end of both to the WebSocket, don't I? Yeah. Okay, so the output is associated with the transmitter. Yes. Okay, I need to fix this to be box connection tx, box new connection rx, comma, save. All right, and then just one error left. This is rx, rx, right? Yes. Okay. It still says I have 2 compiler errors, but oh, they're at the very top. Connection. So this should be connection tx, connection rx, right? And we never use those, so why am I using them? I don't know. Oh, we are using them here. Okay, so we do need them. Then we're, okay, yeah, these are errors, right? So I need, yes, need this to be duplicated. Connection tx and rx. All right. So this is tx connection rx. Yep. More duplication. Splitting it into 2 pieces. All right, it's not so bad. It's not that bad. Okay, now this file is fine. Now we're moving on to the other one. So glad I don't have to worry about keeping those in alphabetical order anymore. It just does it for me. Okay, send frame just takes the transmit end. Good. Moving on. This just takes the transmitter end. This takes both. And ends up not using the receiver end at all, right? Correct. Why did you box that connection again? Because it might be a TCP connection, or it might be a TLS connector from Russell's, right? So if we're going to do WS, it's going to be a TCP stream. If it's a WSS, it's going to be a TLS connector of a TCP stream. Both of those implement the proper traits, and both are probably split in similar ways, right? So it might not be exactly the same. So since it could be either one of these type, and we don't know until runtime because this comes from the URI, which is in the string at runtime. There's no way to know at compile time unless we were to have two different constructors for a WebSocket. One that took a TLS wrapped one and one that doesn't. So I thought that it would make more sense to just use a trait object so that anything that supports this collection of traits, including these two, will work. So it also lets me mock it, right? So my mock connection implements these traits as well. So that's why I have to box it, because we are passing them around, but we don't know the concrete type. Another way of saying it is a trait object size is not known at compile time, and so you have to put it in some kind of shared pointer, and a box is a good choice for that. Probably makes sense to have traits in your case, but there are interesting libraries for mocking concrete structs without traits. Really? I wonder how you do that. They use conditional compilation to generate mocking wrappers when compiling for tests. Interesting. So the concrete structure would have two possible definitions, one the real one, the other one the mock. I'd be interested to see how that works. Okay, fixing errors first. So this should be TXRX, right? Or said a different way, that we pull in the connection only, and then we have to say again, actually, let's search for places, because it might be multiple places. I don't need this open anymore. You can see the whole screen. Yep, good choice. So copy and enter paste. Go back, and this will be RX new. RX TX, go up. Put the TX on the top and the RX on the bottom. Oh, I messed that one up. This should be TX new. All right. So wherever we do this kind of a thing, WebSocket new something, we gotta go say TX box new connection RX. By the way, the box new could go either here or here, right? Doesn't really matter. Okay, so this should be the WebSocket output would be what we receive. So that's a transmitter. Transmitter. It's going to warn me about a lot of backends that aren't used, isn't it? I'm fine with that. TX. We're about to get the onslaught of warnings, aren't we? And this is RX. And that's TX. All right, now do we have all the errors? No, we have one more error in here. Backend. Wait a minute, there's no WebSocket output. Oh, that is TX. Why do I have RX there? Okay, now we got warnings. Let's fix warnings. Probably, yeah, because we're not using the backend for the receive path for this test. Right? And this doesn't use the receiver back in there. And we're going to have a whole bunch of warnings here about similar things, right? So we don't use the back end of the receiver there. We don't use the back, yeah, a lot of these don't use the back end of the receiver. They use the back end of the transmit side. Okay, and then back end of the receiver. Okay, and then going up. Okay, we know we don't use these yet, but we're going to use them soon. So I will fix those later. This, we're only going to use the no for set fin when we support fragmentation, actually. Yeah, and we're not going to support continuation until we do fragmentation, and we're not supporting these opcodes until we support those kinds of messages. So these warnings are all good, right? So just to make sure I didn't break anything, let me run all the unit tests. So all but the last one should pass. Actually, the last one passed too? Oh, this is the builders. Yeah, the builders should all pass. The WebSocket ones, all but the last test should pass. Yeah, and I think the last one's going to block forever. So I need to do a kill. Can I? Oh, when I'm running here, I just... How do I kill it? Control C did it. Is it going to tell me which one terminated? No, it bailed out completely. So, I don't know, should I run... There aren't a whole lot of tests. I'll just run them all manually to make sure that these ones all pass. Pass, 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 pass. Actually, I think I know another way to do this. Yeah, this is the one that flocks forever. Okay, so if I wanted to not run this test, I can mark it config not done yet. Right, and then I can run all my tests, and it won't run the one we're not ready to run yet. There we go, look at that. Isn't that cool? Configurations are cool. It's basically saying this will never be built, so that actually should fail, right? Yeah, it doesn't even find it because it's not in that configuration. Now we'll run it and it'll get blocked forever, because we I think it's getting blocked forever when we do that, right? Actually, this is going to be a problem, isn't it? This will block. We don't want to block forever on that. I don't want to do a for each. I want to do. I want to have it stop after one ping, don't I? Yeah, because we're only going to. What is this again? We're only going to receive one ping. So, how do I do that? Oh, it's been a while since I acknowledged people in chat. Papata Still Papa's been here a while. Hi. Nilanicious has been here too. Hi. Virax, hello. Hope you're all having a great day today. It's already getting kind of dark. It's only 3:30. I hate daylight savings time. It screws me up. Hey there, Sarian. Alright, said hi to everybody. We don't want to block forever waiting for more messages from the WebSocket, right? But what if it sends us 2 messages? Maybe what I should do is have there be a timeout here somehow. Like a wait with timeout. So the timeout, we have access to that because I'm using async standard, right? Yeah, so there should be a timeout. Let's put a bookmark here. I need to drop my old bookmarks. Okay, so I'm using timeout somewhere, right? Not here, but maybe in builders, I think. Timeout. No. Okay, where am I using timeout? In Rust. Oh, in mock connections. Yeah, so I can use this facility to like bail out after a certain amount of time has elapsed. I hate doing this though. It slows down my unit tests. What would I rather do? I'd rather have some way of knowing that it's not going to send me anything anymore. I could have it close. I could close the WebSocket after receiving the first ping. That would kick it out, right? How would I do that? Wrong file. After we receive a ping, if we had access to the connection, we could just drop it. Trait list mocking library. Oh, thank you, Silmith. More homework for me. I love homework when it has to do with Rust. All right. We would drop. What we would do is we would drop the WebSocket. Or no, we should have a method to tell the WebSocket to close, right? Oh, no, wait. Better than that. We would drop the, we would have the connection be dropped. So if I had a wave through the back end of the receiver, so after we send one, we would then drop it. So like something like this, connection back rx dot close or something. And then that would trigger, that would tell the WebSocket that that is end of file, and then that should kick it out of the stream here. We should get an end of file, right? We should get a none. I think that's what I want to do. So let's add that. Pub function close, mute self. How do we do this? I think what I want to do is have something in the shared that says we're going to produce a none. So maybe just a flag saying we've been fused, or it's been, yeah, maybe call it fused. Fused. False. Or I can't do that there. I got to do it down here, right? Fused. False. And then what I can do in poll read here is if shared fused, else if, so if it's fused, then it's going to be ready with none, right? IO result. Oh, I just simulate what we get from a real connection, which is OK 0, right? Yeah, that's a signal of end of file on a on a read, on async read, right? I remember that for the read trait and async read, if it completes with 0 bytes read, it means end of file. So that's what we want to do. And that should be a signal to the WebSocket that it closed. And that, yeah, we want that to work anyway, right? So what this should do is similar to input. It should invoke the waker and all that stuff. So I don't need to get the data. There's no data. We get the shared thing, and then we set the fuse to true. And then if there is some waker, we wake it. And then that will re-enter the poll, and it'll say there's no more data. I like that. That's very elegant. Okay, so then close will fuse the stream in the connection, which should cause this one to complete, and then it should exit. So I should put a timeout on here and declare it an error if it doesn't complete, right? How do I do that? Like an async block here? Yeah. So the async looked like what? I forgot where that was. Show me where it was. It was here. It was timeout given some future. So block on async. Actually, I can just block on timeout, right? And then put reader in face of the future. And I need to say where timeout comes from. Timeout comes from... Oh, yes, kitty? What do you want? There's a loudly meowing cat behind me. Okay, yeah, this comes from async standard, which I think we can get from async timers. But right now, I'm just going to pull it straight from async standard. Okay, so it's going to give me a result, right? Saying if it timed out or not. Yeah, exactly what we want. We want to do a assert that this is okay. If it's not okay, it means it stalled. And so when I run this test now, it should stall and give me an error. Hey, look at that. It failed on the assertion. Yep, it did exactly what it's supposed to do. So now I won't get stuck running the unit test. So this should cause it to complete well within 200 milliseconds. In fact, I can make this longer, right? There's no reason to make this short anymore. Well, I don't know. What do you guys think for if something should happen really quickly, and if it usually passes, is it okay to put a ridiculously long number in here, like from sex 5? And then if the test happens to fail here, you'd have to sit there and wait for 5 seconds before you get the failure? Or should I rather pick something more reasonable like that? Like, it should never take 200 milliseconds to get out of the reader. But maybe on a very, very slow computer, or if you had huge lag, it might spuriously fail because it just took longer enough. It just took too long in real time to get all the way out of this stream. I think this is maybe a good compromise, but if you guys in chat have a different opinion, let me know. I don't want it to be too long because I don't want to have to sit here waiting for that. Right now, it doesn't seem like it's waiting at all. But if, like, I did a from seconds 5 and I hit run now, it's going to sit there for 5 seconds before it says, we didn't get anything. We ain't got nothing. Yeah, I'm going to make that a good compromise. Okay, so then the next thing then, because this is failing, the next thing would be to force close to work. And that is also along the same lines as the reader, right? So something's got to use this reader. It comes back to these warnings, right? If this is what we're waiting on to... this is technically what we're waiting on to receive messages. I need to put this into one feature and then put it in parallel with another feature that handles the receive end of the connection. You put 20 to 50 milliseconds or something like that. 20 milliseconds might be really too short. That might spuriously fail, I feel. It depends on the hardware, right? If I wanted this to test well on my Raspberry Pi, I'd be really nervous about 20 milliseconds. Short as still reasonable, bigger than actual expected order of magnitude. So that's another point I should say is that in the case of this, it shouldn't take that long. It should be so fast that we should always we should never time out here. For some of the other tests where I had a timeout, like it was here. Some of the other tests expect a none for this. And we'll get a none if this timeout actually happens, right? So those where we expect a none, we don't want it to wait. If we had 20 tests that waited 200 milliseconds each, that's 4 seconds it would take to run it, even if it passes. What does it do behind that it take over 20 milliseconds? Context switching. That's what I'm worried about. If this WebSocket is running a worker thread, and the operating system you're running it on will, like it takes a significant amount of time to context. I guess it wouldn't. I guess you're right. It shouldn't take over 20 milliseconds. The only time it would is if we have a thread which is not yielding, and then the time slicing scheduler of the OS might cause it to take over 20 milliseconds how much context switching needs to happen for 20 milliseconds to happen? If a thread is never yielding, then it'll come down to the the OS scheduler to swap out that thread with another one on your CPU core, right? So I'm just thinking ultimate worst case, like we don't yield properly. But then if we're not yielding properly, it's going to break anyway. So maybe you're right. Maybe I could be better than 200. I could just put 20. I can put it at 20 until it fails. Actually, I know what I'm going to do. Can we make a constant that's the result of a function call? Because that would be best. Then I could put in my test a specification for a reasonable timeout. So like something like this, const, in all in caps, reasonable, what are we calling it? Reasonable timeout for fast operations. Fast operation timeout. Can I do that? And if I say that that's a duration, will it let me do that? It will. Neat. So then I don't have to hard code the number 20 here. I can just say timeout, reasonable fast operation timeout. Expected to take microseconds, maybe 1 millisecond, even on Raspberry Pi. Okay. Well, you're giving me the confidence to use a shorter timeout. But now I have it so that if this proves to be a problem, we only have to change it in one place. And I might have other classifications of timeout too. All right, so back to the warnings. So this is one future. Let's start by wrapping it such. So let tx, well, future, well, how about processing tx equal this, right? And then processing tx await, unwrap or. So now independent of that, we'll have a processing rx. And this one will be a little bit trickier, right? It's basically going to sit there and read on the connection and turn it into things we put into this queue and wake up, right? So it's going to be a loop of some kind until when? Until we either close, which we don't have a way of doing yet, or the connection gets closed underneath us. So I'm going to just not worry about the our end closing first. I'm just going to keep it simple. It's going to be, we're just going to loop until the connection reaches end of file. Hey there, Anna, Kim, Luke. I'm doing the WebSocket stuff. I'm just about to start coding the receive side processing. The transmit side looks like this, where we're sending frames whenever the user tells us to send something. And this is the raw frame protocol. I'm actually kind of proud about this. I think it's nicely commented and efficient. We allocate the memory we need for the frame. We put in the opcode of the WebSocket frame. We figure out whether or not we're going to mask the frame's data. We encode the length of the payload along with the mask flag. Then we either mask the data or we don't. If we don't mask the data, it's simply push it into the frame. Otherwise, we have to generate a random 4-byte mask, put it into the frame, and then XOR every byte with that in a rotating pattern. And then we write all those bytes out to the underlying TCP connection, and we're done. If we have any error, then we consider the connection broken, right? So I did all that transmit side stuff. We have tests for it. And now I have to do the receiver end. So this worker thread does both simultaneously. So I'm going to have two processing tasks, and I'm going to join on them, essentially, right? Or select them. The first one that completes should cause the WebSocket to stop. So yeah, we're going to end up doing a select, aren't we? So let processing tx equal, I guess we'll just say receive frames, right? And things we need are the connection RX and the received messages. Right. And so instead of waiting on one, we need to wait on both. So that's future select. And maybe I should cast away the error here at this point. So that would be so this is a future that returns a possible error. How would I do it here? I guess it's we don't care equals processing TX. Nothing. Do I even need to use this macro? Maybe I don't need to do this. We're casting away the results, right? Okay, I already forgot how to do beast. Little bit. You missed the beast. I don't know where the beast is anymore, but he'll show up in my VOD. Is he around? Is he in the? No, he's not in the box. His cat food is though. We don't know where the beast is right now. You have to look back at the VOD to find it. He's been on stream twice today. At the very beginning. So if you look at my VOD at the very beginning, you'll see him. And then about what? Like about an hour ago, he showed up. I can show you the camera. He's not there. See? Not there. RX. Okay. Yeah, I need to go look. How did I do that? Since I don't remember. Oh. Okay. How do I pull it in? I guess it's futures. Yes. So wait a minute. Then why didn't this just work? Is it because I don't have... Let's comment this one out. Oh, it's not a block. It's technically that, right? Yes. Okay. And then end it. And then... oh, this needs to be awaited. And then we don't do that. Maybe not. That's not a feature? Okay. What am I getting wrong here? Okay, maybe that's a problem. Is it gonna tell me I can't do that with just one feature in it? Whoa, that's a long error message. Ooh, no goodness. Shoot. It's almost like I've got a syntax error here. It continues being bad. What if I do that? Okay, that's not the... I think it is the syntax. Maybe it doesn't like commenting out tokens in the middle. So if we put that and comment it out there? No, it's some other syntax problem. Equals arrow, that's what I'm doing. Oh, do I need to fuse it? I probably do. Okay, that reduced the scope of the error. Oh, fuse comes from somewhere else, right? I forget where. Still haven't memorized where all these things come from, so I have to look it up in the manual. Fuse comes from future end stream? Future's future. Future's future. Yeah, I think I'd rather say future fuse. Well, no, we can say future fuse. Okay, that's obviously not right. What am I doing wrong? How did I pull in fuse there? Future ext, maybe? Yeah, probably. Yep. All right. Now we're down to a warning only. The warning is avoid... Oh, I run into this before, and I even have something to suppress it. Where was it? Where was that? It's in one of these, there's like a way to suppress the warning. Was it? Oh, I bet it was at the crate global level. Yeah. This warning policy triggers when future select all is used. Oh, but that's for select all. I'm not using select all. I'm using future select. What's going on here? Wow, scroll forever to get the warning. Oh, thank you for the follow. I'm not... Okay, well, I guess I'll suppress this because why? Okay, let's just suppress it. Allow. That didn't work. Okay, how about inner allow? Can I just do it here? That worked. I hate to do that, though. I guess that's what we're gonna do, though. Put a note. The use of futures select seems to trigger this warning, even though seems to trigger this warning for somehow. We don't know. What should I say here? Somehow that isn't yet understood. So suppress it. Okay, so now I can start to bring in this other feature, right? All right. So I just need to make an async function called receive frames. And a message, receive, yeah, sorry, async function, receive frames, and it takes this end, this direction of the connection, the receiver, and then the receive messages state, and it turns it into a result also, right? Sure. Yeah, because we could have an error, right? Actually, maybe I don't need to cast away the error anymore. If we get an error, we might want to use it. What if I keep the... Oh, that's right, because this... I didn't want there to be an error for exit. Yeah, that's why. I wanted error to mean just stop. We will have already handled the error by that point. So... Actually, I don't need that for... I don't need that for this one. This one can just be a future, right? What? And yeah, it doesn't need to produce anything. Yeah, so it's fine. Why is it an error now? Oh, because I'm not fusing it. There we go, I fused it. How long did it take for me to pick up Rust? When did I start learning it? Like a couple months ago? 3 months ago? It's taken a long time, but it's been very fun. I'm getting better at it as I go. I super love the challenge. You know? And I find it even challenging to, like, once I get it written, to be able to clean it up so that someone else reading it can understand. The best triumph I can hope for is if someone can have a general idea what this does without even knowing Rust. So, like, the best compliment I could get, and it would need to be honest, so don't just say it, but if you honestly think that not knowing Rust, glancing at this code, you still have an idea of what I might be doing, that would be the best compliment. Am I liking it? Totally. I'm totally loving it, actually. To the point where I have kind of put on hold my long-term plans for my game, and I'm trying to incorporate the components in this language back into it. So like this whole thing is for WebSockets, which is one of the core components of my game's client server connection processing. So that's how you talk to my games through WebSockets. So this will at least run server side, and then also the tools I run for automation also run client side. So where was I going with that? This and other pieces that form the core of my game, I'd really like it to be in Rust. Actually, and I think some of the really tricky, pesky bugs I've had in my game, like in the Raft implementation, for example, that I still have, I never got all the bugs out, I think we'll be able to eradicate all those bugs just by moving this to Rust. Once I get this stuff to work, it is very solid. Like, I have yet to see a pesky runtime bug that we haven't been able to solve just by finding a design flaw. All right, anyway, I need to move on. So now we have clearly we're doing two different things. Well, clearly, if you understand futures select, basically this says these are two tasks that are asynchronous, that we don't block on, that we're running in parallel. Basically, we're telling the thread that's getting to this code, run either one. Whichever one's ready, run it. And this is really a loop. You can think of this as a loop that tries to make progress on these two tasks, whichever one is ready. And if neither one is ready, it just sits there waiting for one of them to become ready, right? And the two things we're doing are we're handling incoming messages, which are either to tell the WebSocket to tear down, or we're sending a frame. And the other thing that we're doing is what we're about to add now, the receiving frames back. So this has got to try to read data from the connection, and if it gets data, try to interpret it as a frame. And if it gets a full message, it's supposed to put it into the received messages. So let's see if we get this far. How am I going to test if we got this far? Actually, let's just test to make sure it doesn't break. So what we'll do is we'll just have this never exit. And that's future ready. No, pending, right? Pending. Dot await, I think. Yes, so that's how you say we're never going to finish this task. And that should pass all my tests except for the last one, just to make sure we didn't break anything. Yeah, 4 passed, 1 failed, the receive ping. Okay, good. I didn't break anything. I like to do that check every once in a while just to make sure that as I'm adding more code that I don't break existing code. Can Rust compile to WebAssembly? I believe it can. And I might. And Kim Luke. So what one of my streamer friends, Chris Griffin, was talking about was doing U. So this is a WebAssembly framework for Rust. And I would need to study this. He has, you can see there's a ton of contributors. He has shown this on his stream, and he's using this for some of his projects, but I haven't stepped into it yet. But yeah, I'll probably look at into this at some point. You? You, not ew. There's a lot of puns you can make too. Like, he made a presentation on Rust in WebAssembly, and he said at the end, well, thank you. No, thank you. Thank YEW for watching. Anyway, bad puns. All right, receive frames. So instead of waiting forever, let's start pulling in the code that I had for C++. So the way that worked is instead of polling, it waits until receive is called, right? Yeah. So let's pull in this stuff. Yeah. So we're gonna have a frame reassembly buffer, and we're gonna make sure it doesn't get over a certain size, and we're gonna constantly be trying to parse frames out of it. So this is the core of the receiver here. So in C++, what it's doing here, just to go over it, is because in C++, we got to deal with potential null pointers. If we have configured a maximum frame size, Then we see if the data we received so far plus the data we've just been given is over that size. We're going to say, no, this frame is too big. We can't keep parsing, right? So if we don't get that, thank you for the follow, by the way. You can relate to bad puns, that's good. We put the new data into the back of the reassembly buffer, and then we see if we haven't yet gotten 2 bytes, we can't even look at it. If we've gotten at least 2 bytes, we can look and see if the, what's this mask flag? Why is that mask? Oh, this is the second octet. So, right, the first length octet is the second octet without the mask bit. Right. And then if it's one of these special markers, that means that the header is a certain size. And then once we know the size of the header, we check if the buffer, if we haven't received all of the frame yet, we return early. Otherwise, we can decode the length of the payload. And then because we've already done the check to make sure we've received all the frame or not, if we get to here, that means we've received the entire frame, right? So then we would see if the mask bit is set, then we need to incorporate the mask, and then we might not have received all of it yet, so we can bail early. And if we have received the whole thing, then we go into consuming a frame and then draining that out of the reassembly buffer. So receive frame is going to interpret the fin bit, check the reserved bits are all 0, make sure the mask is correct for the role that we're in, recover the opcode, do the masking if necessary, or the unmasking, and then switch on the opcode. A continuation opcode means we're going to yet another reassembly buffer where we have a higher order message reassembly buffer that we add the data to. And if the fin bit is set, then it marks the final fragment. And so if we're receiving a text message, we can send it up to the user as a text message. If it's binary, binary. Otherwise, we didn't expect a continuation frame, right? If it's a text opcode, that means it's either a complete message or it's the first fragment of a fragmented text message. If we were already in the midst of receiving a message, so we're not in the none state, then that means we lost the last fragment of the last message. Same thing with binary. A close has special processing here. If we receive a close frame, we're supposed to report the close back up. If the reason phrase is valid UTF, if it's not, we have to close RN immediately and say the close reason had an invalid data in it. And there's this special processing where if we're already in the failure mode, we will close right away. Otherwise, we wait for the user to close their side of it. And then ping and pong are really easy. We already have some of this, right? The ping, if we receive a ping, we're supposed to send a pong back, as well as tell the user. If we receive a pong, we just tell the user. If we get anything else, then we close because it's some kind of like damaged bit stream. It's an unknown opcode. So I need to port all of that to Rust now. So from what I got out of that was we'll need a frame reassembly buffer. We'll need a message reassembly buffer. We'll need to know if we're in a, what's this fail flag? Oh, that's set there. And set, okay, that's what that's for. We need 2 reassembly buffers at least. What else? We'll need a mechanism to close. All right, so let's at least do this first part. Well, where do we put the reassembly buffer? This runs in a loop, right? So we can just put the reassembly buffer here. So let frame, well, what if I just globally select and then snake case that one? And then, so we say that is a vector of bytes. Vec new. Done. Okay, the message reassembly buffer. Let's do that in another place. No, we should do it here. We should do it here for a good reason in that this is this encompasses the entire task. So when we get down to here, we'll have to actually, you know what that makes me think? That we should have some extra state associated with receive frames. No, well, this runs as a task that can't borrow anything, right? So we got to put everything in here. Yeah, all right. I'm thinking out loud about how I would structure this. Receive frame is called here. Oh, what was I trying to find here? Oh, I was trying to go into there to see what the message reassembly buffer looks like. What is that? Oh, it's just another buffer. All right, fine. So we have two of them. Message reassembly buffer. Okay. I will want to be able to let the user configure the max frame size. Right now, maybe we'll just keep it as a constant. And I should look to see what the default is. Max frame size. What is the default? 0, no limit. Okay. How about we do, I'll handle that later. I'll put a to-do here. To-do, here is where we would enforce a maximum frame size if we had a way to configure that. And actually, what if I put it in now and I'll add later the way to change it. So that would need to be, oh, why am I in the C++? I don't know what I'm doing. I'm in the wrong file. Go to the Rust file. There we go. Here's where we would do it. All right, but we can do it right now. So the to-do would be, we will need a way to configure the maximum frame size. So it needs to be passed in, right? So max frame size is an optional usize. So right now we'll just pass none. None. All right. But we'll need a way to configure it. So the way this would work is instead of an if greater than 0, we say if let sum max frame size equal... Oh, this needs to be in a loop too. The whole thing needs to be in that loop, right? Yes. Hold on. Indent. End indent. Lol. What are we lolling? There's a bunch of Rust sites that pattern, are we blank yet? Are we... Oh, yeah. Yeah, Chris told me about that. There's are we game yet? There's are we learning yet? Are we learning yet? Oh, machine learning. Okay, I was like thinking, are we learning Rust yet? And maybe it would catalog all the learning material about Rust. So this is about machine learning. That's cool, though. They tell you, oh yeah, we got clustering and we got decision trees, but we don't have GPU computing yet. That's neat. Okay, anyway. If we have one, then if essentially this part, configuration max frame size just is max frame size, drop this stuff. Excuse me. Size becomes len. If it's greater than, okay, we need to have a mechanism to do close. I don't know how to do close yet. So I think what I'll just do is comment it out. And actually probably how I would do close. It needs to transmit something, right? Is we would, let me think about that. I don't know how to do close yet. I think I'll just leave it commented out. And then we do want to return early though. Yes, we want to do at least that. Yeah, let me actually comment all this out so it actually compiles. and put, yeah, so data becomes, oh shoot, we're missing one key thing. We need to actually wait to get more data. So wait for more data to arrive. And I need to make space in the frame reassembly buffer for that. So, actually, then it sort of goes along with this. How would I do this? This check actually really doesn't belong there. It really belongs where we get the frame length, right? Or I guess the other way to think about it is if we fail to reassemble a frame, but we have over max length of bytes in the reassembly buffer, then we should bail. I mean, because the frame is obviously bigger, but then we'll know because we'll know the length. So wouldn't it make more sense to do this check down here where we know the payload length? I think it makes more sense to do it there. Okay. Should I say that somewhere? No, I'll know to do that. So yeah, wait for more data to arrive. These both need to be mutable. Because I'm going to do the same kind of trick that I did in the server. Where was it? HTTP server. I hard-coded this number, yeah. So I don't really want to hard-code that number, actually. I kind of want to make that a constant. It's how many more bytes we want to receive in one go. Like, how many bytes are we prepared to receive? So it should try to be like the typical frame size. But we don't know what the other end is going to send us, so we could either make it adaptable or we can just pick a random number like that, which I'm inclined to do right now. Maybe put a to-do layer to say that the amount we allocate in advance ought to be like something that we adaptively figure out based off of the traffic, maybe? And we start at some initial guess. Because what we want to do is minimize the number of loops, right? The more loops we have, the more overhead. But if we allocate too much memory, then we're wasting allocated memory just to avoid looping. You see how that goes? If we could just read one byte at a time, that would be the most memory efficient, but it'd be horrible in overhead. Yeah, so it's the same thing. We need to know the leftovers. I'll just copy this. We need to do this, right? I need to do that. Wait for more data to arrive. So it's frame reassembly buffer instead of receive buffer. We resize to be the leftovers plus some random number, which I'm going to leave random, and put a to-do. We have a magic number here to indicate a guess, or as a guess, of how much more memory we will need to hold the next frame. We can do better than that. Perhaps by making it configurable or adapting at runtime based on like how far off we were, how far off our previous estimates were. So like as we receive frames, we would every time we didn't allocate enough memory, the next time we would allocate more. And if we got to the point where we were always allocating too much memory, we would dial it back until it kind of like floats around the correct amount of memory, maybe with a little bit of overhead. Hey there, JB Pratt. How are you doing today? Look at those Mr. Halsey clippies. Shout out to Mr. Halsey. I was watching a little bit of his stream this morning. Everybody in the Rustations team is an awesome streamer. Awesome streamers all around, especially if we like Rust. Okay, this connection is connection RX, and we should be able to read it and put it into the frame reassembly buffer and wait for that. The error we want to handle especially though. So I think I want to do an early return out of that. So how do I do that? I would do something like end it early there and say if is error. Okay, what's wrong with this? There's something wrong with this code already. The read is off. Why? It doesn't know it's bytes, I guess. It should know that that's bytes, right? Async works with bytes, I thought. Unless it doesn't know what the read is. Oh, no method read. Oh, shoot. We need to pull in, what is it? From, yeah, async read extension, I think. I need that. That goes under futures. Yes. Need the reader extension. There we go. Okay, now we're good. What am I working on? Hey there, Brad. Let's try to keep politics out. I'm actually streaming because I don't really... it stresses me out to watch what's going on with politics. So let's try to make this a politics-free zone. What I'm working on today is an implementation in Rust of WebSockets. WebSockets is a neat protocol where you can have bidirectional communication between a program and a web server. So things like chat rooms. And you can send text or binary messages or pings back and forth, and neither end is considered the passive or active end. They're both active. And it's not the first Rust implementation of this. I'm doing my own because I enjoyed doing this kind of thing. If you're interested in something already pre-made, I'd recommend the Tungstenite library, which is the wrong place for me to search for it. If you go to like libsaurus or crates.io, Tungstenite. So what I'm approximately doing is making my own version of this. So they show how you can connect to a WebSocket server and just start sending messages to it and receiving the replies back, I guess. And it's pretty cool. Why did I minimize that? I didn't need to do that. All right. Sure. The Tungstenite's the synchronous version, so put async in front and you get the asynchronous version. Mine's also asynchronous, which you can tell when you see either the async keyword in my code or you see futures mentioned anywhere. So yeah, this might be really hard to understand unless you know the Rust programming language and or what WebSockets are, but I hope to explain as I work like what I'm doing. And if you have any questions, please feel free to stop me. Okay, if I get an error, I think we want to break out of this loop. For now. In the future, we might want to... Well, no. If for any reason we can't receive any data, it means that we're done with this future, right? We just bail. I'm okay, Batcraft. How are you today? Let me give some waves to Brad and Batcraft. Yeah, so we're handling errors right now in a very basic way. We're just stopping our loop if we run into an error. Okay, and then... Actually, I think I need this and then... Yeah, so this should be reseed. I kind of feel like this whole thing ought to be inside of an async that... Yeah, I think I'm going to do that. Async function. It should be inside of a subtask that we can do the question mark operator on early. So this one will return a failure, right? Receive bytes from this, and we'll borrow it mutably. We'll borrow the connection mutably, and then we'll also borrow the reassembly buffer. So frame reassembly buffer, borrow mutably a vector of bytes, right? And then what we're going to pass back as a result. The result will be nothing, right? Or will we want to know the number of bytes we read? What comes next? We're just going to study the reassembly buffer afterwards, so we don't need a result here, but we want an error, which we are going to discard from receive frames for now. But it allows me to use the question mark operator, which is really cool. So that's this part. Right there. Grab that, paste it here, unindent. We still have the magic number in there, that's fine. So, I don't need, I can do that now. Actually, I need to do a map error. Map error to, we need to invent an error for this, right? Do I already have one? Do I have an IO error here? I have a connection broken. Would it be a connection broken if we couldn't read? I guess it would be. Connection broken. There we go. Question mark. So we don't need this break, right? And then the and then. And then with the received data, if we got nothing, then it's also a connection broken. Well, it's actually a different one. A connection broken without an error would be called what? A connection closed? Connection closed. The underlying network connection was gracefully closed. Whereas this is an ungraceful, like a reset of a connection or something. The underlying connection was gracefully closed. So there's no source for that because there doesn't need to be. There's no error. There's no underlying error. That goes there. Okay, and then if we do receive data, it's the amount of data, which goes into there, and then we truncate, and then we need to return something, which is going to be okay. Okay, what's wrong with my and then? Oh, that is from another trait, apparently. Which trait did I pull that from then? And then, where do we get that? I'm not sure. It looks like I'm getting it from result. Wait. Oh, there's no question mark there. The question mark goes down here. The and then is if we don't have an error. Right, I do that because we have two possible places where an error could be generated, and I only need one early return. Yeah, there we go. So now it's good. So then I can say here, receive bytes, borrow the connection, borrow the, and this needs to be, borrow mutably the connection, actually. Borrow mutably the frame reassembly buffer. And if this is an error, break. I was hoping that that would wrap that in... Oh, because we have errors, it won't. Shoot. So... I'll do it myself, because I can't stand it. Is it because of that dot? And probably all this junk? Yeah. Alright, so this should be an await is error. What else am I doing wrong here? This is just wrong for now. Let's just comment this out. And I don't need that yet, so I'm going to comment that out. I just want to get it back to where it compiles again. It's not declared as mutable. Well, let's make it so. These other things ought to as well. This one doesn't need to be. Alright, cool. So we're just down to warnings of things we don't use yet. That's neat. Okay, so after we receive data, we would proceed directly into checking its size, right? Oh, it screwed up the formatting of that. Damn. Okay. I'm going to start deleting from here and then pulling in... Actually, I don't even need to pull it. Yeah, maybe pull it back in from the C++. I'm porting this code from... the original time I wrote it, I was in C++. It's ugly as heck, but that's okay. You know what? We're fine with ugly code because we're gonna clean it up. Okay, after we receive more data, keeping that comment around, what are we doing next? We are saying if we don't have, so this needs to be converted to snake case. If the sizes become lengths in Rust, this is saying if we don't have even 2 bytes yet, we want to break out of this. Oh no, we want to continue actually and wait for more data. That's what that means. So proceed only if we have enough data to recover the first length octet, because that tells us how long the length is. All right, so I guess here figure out the payload length based on the first length octet. It will be either 1, 2, or 8 bytes long, depending on the value of that first byte. We may loop back to the top if we find that we haven't received enough bytes to determine the payload length. All right, so then const auto just becomes a let. This, we need to make the snake case. All right. We do have mass. Can I not do a bitwise inverse on that? Why does it say expected comma? I don't know why it's saying that. Anyway, yes, based off of that first byte. So the way that I do here in C++, where you figure out something and then based off of if let, we can do that with a match. Bitwise is, oh, it is? So I do that? That's useful. Thank you, Sarian. You get a point. All right, but I give a warning here, probably because, yeah, it says I don't need the parentheses. Thank you, linter. So we have the length first octet, and we will, we're going to do a match on that, right? Yeah, let's just do a match now. Match on that. If it is OX7E, then this first part, right? Okay, and what we're getting out is going to be the header length, payload length, right? Equals that. So for 7E, it's 4. So let header length equal 4. If we don't have enough bytes to interpret the length, then return. Otherwise, let the payload length. And there's where I need to do some shifting. So we can do that at, whoops, as usize plus that as usize, right? And what is it going to tell me about that? Unnecessary parentheses. All right. No parentheses then. I'll let the formatter deal with that dangling semicolon. Okay, so what we return from this arm is header length, payload length. Actually, when I think about this, yeah, I don't want to say 4 more than once, so I like the way that looks. That's one arm. You could cast before the shift. I should cast before the shift, shouldn't I? Yeah, I was doing that before. Thank you for pointing that out. That's a bug. I'm surprised that the Rust didn't tell me that I'm going to lose my data that way. It probably needs more parentheses, right? Yeah. Interesting. Do you see how I misinterpreted those characters? It said, less than is interpreted as a start of a generic arguments for use size, not a shift. I've never seen that error before. And actually, does it propose what I do? Quick fix. Try shifting the cast value. Oh. It ended up putting parentheses around it for me. But then, do I need to keep these outer parentheses? I kind of want to. Anyway, the next arm is 7F. Actually, in the other code that matches this, I use the decimal numbers, right? So 126 and 127. Right. So it's this block. Let header length equal that. If we haven't yet received enough data, Actually, we don't want to return. We want to continue, right? Oh, I know how I want to do this. I should make this a oh, this is you guys are not going to like this. I'm going to have an if let sum because here I can have none, else sum. No one's going to like me doing that. None, else. Thank you for the follow. I feel like I'm making horrible code, and I don't appreciate. I don't deserve the follow, but you know, thank you anyway. Okay, and then the else will be the first length octet is this. So I don't need to give it a name, but I will. And so this is that as usize. And then the same thing here, right? So that... Okay, let me comment this out for now. And fix the warnings here. So if it is some, then we're going to do something about it. Okay, now what okay, these typecasts are wrong, right? And this, yeah, it's because of these. So I can go through and everywhere we have, oh, it's going to stop on that. Shoot. Okay, but I can do that as usize, then shift. Okay, I can do all these in one swoop like that, right? And then add a parentheses. And then all of these, come on. Come on, editor, work with me. No, right there. There, no. Not there, no. As usize, parentheses. And get rid of the excess parentheses. And this one doesn't need that one. And this needs to be as usize. Okay. Length versus octet. How come it's not letting me... Oh, these have to... Yeah, whenever you make tuples, you need extra parentheses. Yeah. There we go. And that goes there. There we go. And what's wrong here? All right, this needs to be another thing, right? So what I ended up doing here was a match whose results get fed into an if-let so that we do the rest of the body of the work only if we get a valid header length and payload size. If not, we're going to skip anyway. So this avoids me having to do a continue inside there. Vim. I like VS Code, though. Okay, it screwed up my code here, didn't it? Shoot. I hate that. It reformats inside the comments, which screws this up. Yeah, okay, so we need to do that. Again. It's this one, right? If the mask bit is set, we need to add 4 to the header length. Then we return early if we haven't gotten a frame, and then we do these things. All right, so that goes inside of here. Like that. And I'm going to move that to after we figure out the header length, I think. Actually, I ought to do the check. No, that's if it's less than 2. Okay, so then in the else, I should check if the length is too big, right? Yeah. Okay, bear with me. So I don't need... So I still want that to do. I can drop these lines now, though. We do want the return because that means the stream is broken if we get something that's too big. So if there is a max frame size and our reassembly buffer is now too big, in fact, greater than or equal to, then it's too big. All right, and then, all right, so then the mask bit. If the mask bit is set, then we need to add 4 to the header length. So that means this needs to be marked as mutable because we might change it. All right, so then sizes become lengths. If the number of bytes we have is less than the number of bytes in the header plus the number of bytes in the payload, then we wrap around and continue. Otherwise, we're going to receive the frame, which we don't have a function for yet. Receive, what am I doing? Snake case. Header length, payload length. Actually, we don't need to do that, right? Oh, we might need the header length. What do I use the header length for? I use it to find out where in the frame the data actually is and where, yeah, so we need that. Header length, we don't need the payload length though. Do I? Do I need that payload length for anything? I suppose we'll keep it, but we also need the frame reassembly buffer. We need to give them a slice of it. So slice frame reassembly buffer up to, actually it's this, right? So why don't I pre-compute that? Let frame length equal that frame length, because we're going to slice it up to frame length and give that to, give that to the receive frame function, which we haven't written yet. And then we are going to do a, I hate to do it. I'll clean this up later, I promise. We're going to do a drain. We're going to drain out that same range after we've fed it into receive frame. Let me put a to-do here. This is expensive, especially if we get a large number of bytes following the message we just received, the frame we just received. It would probably be better to, I don't know. Well, let's just say, look for a better way of handling the leftovers. Probably with a swap or something, right? Or maybe with slices? I don't know. Mutable slices? What comes to mind is a ring buffer, but then our frame gets fragmented into 2 pieces, which I don't like. It wouldn't be too terrible, but we could reassemble them inside a receive frame and just pass up to 2 slices from the ring buffer. Tell it, hey, these are two slices. Recombine them to get the frame. Anyway, that gets rid of that. And okay, here's where there's a problem, right? I want to do this check in 2 places. I want to do it there, and I also want to do it here. And this should be if the frame length is bigger than the maximum frame size, then it's too big. I'm missing a bracket there, aren't I? There we go. Let the formatter fix it. Okay, so I need a receive frame function. And this needs to borrow mutably the reassembly buffer, which we don't have yet. Okay, so need the reassembly buffer for that. And it also needs the received messages too. So borrow that mutably, Also borrow the receive messages mutably. Where to put that? At the end, maybe? All right. I think that's all it's going to need. So let's define that function. That is synchronous. Reassembly buffer is a vector of bytes. Frame reassembly buffer is... we don't need... Actually, yeah, it's a reference to a vector. Frame reassembly buffer is a slice of bytes. Header length and payload length are both sizes. Receive messages is this guy. I don't even need to borrow that mutably, do I? I can just borrow the reference immutably. So that doesn't have to have a mute there. All right. Cool. So then what this would do is nothing right yet. We should see if we even get that far. Which means that this doesn't need to be mutable. All right. And so now we're fixing warnings. Those are all warnings because we don't use them yet. Okay. Yeah. I think we're good. So I'm going to run my test again to make sure it gets that far. No, I got a try send error disconnected. There. Ooh, how did that happen? It got an exiting somehow. Probably need some more print messages, right? I think I might know why. But I'm not sure. Let me check. We should say something like handle messages. Where is it? Handle messages prints when we get stuff, right? So we should probably print something here too. Print got exit message, and then we should probably print when we get data. So print line reading more data. And this would be error, well, unable to read more data. Connection broken. Thanks for the follow. I should say here receive frames. I'm putting like old school debugging in here, right? That's fine. Old school debugging is fine. Receive, why am I typing? It's in my clipboard now. Received some bytes. Now, we now have some number. So that is, okay. We should move that into here. Yes. This is received bytes. Received bytes. We now have received plus leftover plus received. All right, and then let's print stuff here like receive frames, not enough bytes to decode length, frame length. And then if we get into here, let's say receive frames. Next frame is header bytes, payload bytes. Header length, payload length. Okay, that didn't format it for me, so I gotta do it myself. You're horrified? Wait, Clippy isn't warning about taking a mute box when you don't do anything with the box itself? Am I doing that without thinking? What did I do? I'm not taking a reference to a box anywhere. Where do you see that? Oh, here. Don't I need to do that? Do I not need to borrow that mutably? You saying I could do that? No, because this says it needs to be behind, it needs to be mutable. Or are you saying that I should just do a reference to a dined box? Can I do that? What's this? One guy has resubscribed for 8 months. Thank you, one guy. I appreciate that. By the way, I think you're a VIP now. I went through my subscriber list, and I think I made it everyone either a VIP or a mod who has been subscribed for like a long time. So 8 months is a long time to be subscribed to me. There you go. Look at that nifty diamond that you have, and hey, how are you doing today? So yeah, Sarian, I don't know how to do it with without keeping the box there. Do I need to do... I don't know how to do this. Can I do that? Yeah, I just don't know how to do it without doing that. Maybe you can teach me how to do it. See, I'm borrowing a box. I don't know how to do it without borrowing the box. I have to have the box at some point because the size of that's unknown. Mute dine connection? So you saying I can drop that? Oh. Thank you, Sarian. How am I going to memorize that? There was a mutability error. Okay. The reference gives it a size, so that means I could do that. I just needed it to be mutable. Oh, okay. All right. All right. I'm trying to learn. I'm trying to learn. So this just works. I didn't have to change the color at all. Okay. Should I look for other instances where I did a reference to a box or mutable reference to a box? Here's another one. I can just strip the box away. And that broke something. Oh. That's a problem, right? Or is it that... Do I need to do something like that? Okay, that broke send frame. Send frame broke when I did that. So how I'm passing the reference to send frame is a problem. If this box is inside a ref cell, then how do I borrow it? Let's see. Cell cannot be shared between threads safely. I don't mean to share a cell. Hey there, Musen. How are you doing today? I need to deref this syntax somehow, like that. There we go. So I didn't even need the parentheses, you're saying? I felt like the parentheses were needed there. It's starting to come together in my head, of like in the intuition on what to do to reference and dereference when it needs to be done. What trips me up, I think, is that Rust does a lot of the dereffing automatically now. But here's one case where it couldn't do it automatically, right? So it couldn't figure out how to make that work, and I had to say, well, you need to dereference that first, and then take a mutable reference to the inside of the box. Yeah, to it didn't know enough to reborrow, right? Okay. By the way, I don't know if you need the promotion, but Musen is an awesome Rust developer. He knows the most of any of us, I think, about Rust. And check him out. He's doing random projects in Rust all the time. Okay, that's the send. Where was I? I was in receive, right? Yeah. I wanted to make sure that this ran without crashing. Okay. Did it fail where I wanted it to fail? Receive ping is the one that should fail. I got... Yeah. Okay. Cool. This is where I was hoping it would happen. So this is preventing a deadlock. Basically, if the reader never completes, the test would never finish. So we put a reasonable timeout on it. So this means that we never got the message received, which makes sense because we actually should have sent it from here and we never did. All right. Final home stretch for WebSockets. So the code for receive frame, basically we have the frame and we need to interpret the frame, right? Which means reassembling messages and that kind of thing is here, right? It's this code. There's a lot of it. I don't know if I'll get all of it right now. Maybe just pings. That's all we need to get, right? So maybe for now I will drop the other kinds of opcodes. In fact, we'll drop continuations. So we'll make it easier on me. I'll do the continuation stuff some other day. We'll just get ping working. So just ping, nothing else. We'll close on any other kind of opcode. So that simplifies the code a bit. Why do I have an early return on close? We're ignoring any data that we receive after we receive a close? Probably. I don't know if I need to do this. So to do, I don't remember if this is actually necessary. Receiving data after we have received a close frame is illegal, but in this implementation, we may have completed the worker thread's tasks and never even try to read more data from the connection. So I'm going to leave this commented out. Right now, in the old C++ code, what it did is if we received another frame and we've already received a close, it would just ignore it. So it would just be the equivalent of that, right? But I'm going to comment it out for now. All right, so next is decode the fin flag. Constable becomes a let, and then its frame reassembly buffer is snake case, and then we don't need extra parentheses. It's if when we mask the first octet or byte with the fin flag, if it's not 0, then the fin flag is true. Cool. Now, decode the reserved bits, and if we're returning errors, I should have it return an error, shouldn't I? And then if here we're just ignoring error, yeah, so I should do this. I should say, if this is an error, for now, we're just ignoring the kind of error. We're just going to do a return, right? So make receive frame return a result. Don't need any data, just catching errors here. So that I can do, I can encode these as actual errors, which is what I want. Yeah, I need to figure out the semantics, or like how are we going to close things. I don't know about that yet. I'm going to keep that commented out for now. Decode the reserve bits and reject the frame if any are set. Since we don't support any use of the reserve bits at this point, let reserve bits. But we still should check them for correctness. Equal that pattern. So shift right 4 and isolate them should give us a U8 with just those bits in it. And if they're not 0, then we'll figure out the close later. Right now, it's just going to be a return. Well, we already have a return. You know, do I even need an error here? I kind of feel like if we're not going to use it yet, I should have an error. Yeah, eventually I'm going to want to percolate this up to the user somehow. So let's add a, maybe just make it generic, like improperly encoded frame or something. Bad frame? Bad frame? error. I could include the reason here too, you know. What if I do that? Can I not do that? Oh, it's probably because this is not closed, right? Yeah. Okay, well, a valid frame could not be well, actually, it's not that it couldn't be constructed. A frame was reconstructed from the receiver, which I don't know how to. I'm bad at English. English is hard. You can also coerce an arc into a reference to a T, but not a mutable T. Yeah, to get mutable, you need an interior mutability, like a mutex if you're using an arc, right? And I am planning to use the asynchronous mutexes, but today I'm lazy. A frame was reconstructed from the receiver, which is bad. How do I phrase that better? How about, well, it's going to be the last frame reconstructed from the receiver was bad. Okay, and then we'll have in the comments here, this is, this indicates that the last frame reconstructed from the receiver was bad. The reason why it was, well, a human readable explanation of why it was bad is included. There we go. That's what we're going to do. So then I can say something like, return error bad frame, reserved bit set to my heart's content, and worry about the close later. If you have a single owner for an arc, you can use arc get mute. Yeah, I read about that. It uses the borrow checker to enforce that. Yeah. Can't be any weak pointers to it either. Right. Because you can conceivably from a weak pointer recover the strong pointer. And there's no locking mechanism in an arc, right? Alright, so then continuing on. Decode the mask flag. So that's another easy one. Just let the mask be equal to that. Alright. Verify the mask. Oh, that means I'm missing an argument. We need to verify the mask flag is correct. If we are supposed to have data masked in the receive direction, mask should be set. Otherwise, it should be clear. So I need that handy dandy enum I made. Mask direction. Where to put it? What about here? There we go. So when we call receive frame, we need to tell it the mask direction too. And this needs it then too, right? We need to percolate that down. So sure, put it there. Receive frames is called down here. And this has the mask direction. Cool. And it doesn't want to wrap that, so I'm going to do it because that's way too long for me. All right. What is Rust? Yes. Actually, I know more streamers who know and use Rust. It's a programming language. It didn't help? Oh yeah, that command assumes you know what Rust is. Rust, when you say Rust, you could actually mean two things. You could mean the Rust game, right? Some people like that game. Or you can think of the Rust language, which is what we're doing, which you can read about more here. It's a programming language similar to C, where it's low level, so you can write a kernel in it, but it also has extra tools in the toolbox, so to speak, for reliability is the main thing. That there are strong guarantees of memory safety and thread safety, which make it really challenging, in my opinion, to write, but very rewarding when you get it working. So when you see things like box and arc and stuff like that, and ref cell. These are all extra things that have been added to the standard library and the language itself to help enforce those guarantees of safety in memory. So it's very, very hard to access an invalid memory location in Rust unless you open up what's called the unsafe tool chest. The Rust game is where you get a bunch of red, yellow, and green and blue squigglies, and you're confused as to why not compiling. Good one. There's that kind of game, yeah. But we've had people come into the stream and assume that we're playing the Rust game, that we're maybe making a plugin for the Rust game, but no, this is a programming language. I don't think I've ever seen a blue squiggly, unless it's in English text and it's indicating a grammar error or something. So overall, what my long-term goal is to make my own game, which you can check out there. I'll give you a brief glimpse of it. It's running in AWS, so it's always online. There's no content in there yet, but there are some test NPCs like George. There's some slimes. This is a sewer area. And the core of this game right now is in C++, and I've been wanting to convert it to Rust ever since I started learning Rust. So part of my game's connection between client and server uses WebSockets. We could pull down a pre-existing library like Tungstenite or Async Tungstenite to do WebSockets, but I enjoy doing stuff from scratch. I learn a lot. I've learned a lot about Rust just trying to make my own libraries to do things like HTTP and WebSockets, and so that's what you're seeing me do today. The today command will give you more specifics on what we're doing today. It's WebSockets. If you want to read more about WebSockets, it's this RFC. And a brief intro is this is what the line protocol looks like. It's a way to wrap messages, called the payload here, and pass them in one of two directions, kind of like a socket that an operating system would give you, only it's built on top of the web. So to make one of these, you start a web connection, like if you're doing a GET, and it looks like this. It's a special kind of GET because there's an upgrade token in the connection header, which means we're going up, and we're going up to be a WebSocket. As long as we have a key that matches the accept from the server, we get promoted. We promote the underlying transport layer connection to a WebSocket protocol. So you send a GET that formatted like this, and if the server sends you a response that says switching protocols to WebSocket, then you stop talking HTTP and you begin talking WebSocket, which is, like I was showing here, this is the format. It's binary wrapper. So to give you an example of what a real message looks like, I'll show you my unit test. Here is an easy to understand one right here. When we send a ping that has the string hello in it, we see hello on the wire, but we see two little strange bytes in front of it, an 89 hex and a 5 hex. And those correspond to these two bytes here. 89 would be the fin flag is set, meaning this is the final fragment of a message. The 9 stands for the opcode, which 9 opcode is a ping, right? And then the 5 here is the payload length with the mask flag off, which means there are 5 bytes, and here they are. If the mask flag was on, we would have a masking key, and the data would be indecipherable. And for an explanation about why you'd ever do masking, I would refer you to the RFC to read about it. Suffice to say, we have to do it, which leads to some interesting looking code, like in here, where if we have to have a mask, we're going to use a random number generator to construct a mask for every single frame, because you're supposed to do that, and push it into the frame, and then you apply the mask by rotating through that mask key an XOR. So byte 0, 1, 2, 3, back to 0, 1, 2, 3 for the masking key. That's what this mod 4 does. XOR that with all the bytes of your payload, and you push that into the frame. So basically it makes it, the short of the reason why you have masking, by the way, is so to prevent poisoning HTTP caches. Because conceivably, an attacker could put in a payload that looks like an HTTP header, and it would make it through it would make it through the proxy and not get caught because we've upgraded the protocol to WebSockets. But the proxy would say, oh, that looks like a header, let me cache that, or let me change my cache. So to prevent cache poisoning, the protocol requires that for a client, an untrusted sender, that meaning the client, its data has to be masked, and it has to be a non-zero mask. So, and I think it has to be rotating too. So the server can be, a really strict server would make sure the mask is present, the mask isn't zero, and the mask is rotating. Anyway, I've over-explained that. I'm allowed one over-explanation per hour, right? Also, masking is used to limit frames to a certain size. No, the masking really just applies a cipher to the payload. The what you saw there with the size is just a way to compact the header. If the length of your payload is small enough, you only need 1 byte for the length. And then there's a medium-sized frame where you use 2 bytes to encode the length. And then if it's bigger than 64K in size payload, then it just defaults to 8 bytes for the to encode the length. And technically, there's no length limit, but the longer you make a frame, the harder it is to multiplex in things like pings. And also, the other thing is you only certain kinds of frames can have lengths in this category. The control frames have to fit into this category. So like a ping can't be more than 125 bytes of payload. And we have to have special checks for that. So you like the explanation? Yeah, I try not to over-explain that because as you know, people who have been watching the whole stream kind of probably get tired of me explaining the same thing over and over again. By masking, I mean figuring out which control frame is which. So that's the opcode. And right now, I'm only going to support one kind of opcode. But yeah, the opcode does control certain things, right? So text and binary are allowed to be fragmented, but control frames like ping, pong, and close are not allowed to be. There are rules in here that say that. It's a fascinating protocol. Simple, yet complicated enough to form a challenge to anyone trying to implement it correctly. All right, should I just follow the trail of compiler errors? Yeah, here's where we were, right? So if there's a mask, so I didn't like the way I did it in C++. I didn't want to keep the role concept this deep. I wanted to use this mask direction. So we should say if mask, then if mask direction is not equal to, well, I should keep it positive logic. Mask direction. Oh, I'm doing this wrong. Shoot. How do I do this? If let mask direction transmit, right? I'm going to get this backwards. I know I'm going to get this backwards. I get it backwards and my test will fail, and then I'm like, oh yeah, I got that backwards. All right, so we're going to have this, right? Masked frame is bad in this. So if it is masked and we only mask the transmit direction, then it's an error, right? Otherwise, it's an error if it's not masked and it should be, then it's an unmasked frame error. Oops. Okay, I'll deal with the closes later. I'm not going to deal with that now. This should be unmasked frame and single equal. And it's going to tell me that I could have made this cleaner, right? Yeah, it could be collapsed. Do I really want to do that? If it has a quick fix, I'll try it. I don't know. That breaks the symmetry, doesn't it? Doesn't that break the symmetry? I like the symmetry of that. Maybe I, for the sake of artistic license, I will allow that. If matches, oh, that's right. I keep forgetting to think in terms of patterns. I could collapse this with a big match, right? You are correct. Of course. Musen has great points. Don't you agree? So match. Yeah, I was gonna do. Yeah, yeah, you're right. I can even reduce it further by saying if matches. Yep. Let's just do that. If matches, mask direction, comma. Mask. One of two patterns, right? either it's true and the direction is transmit, or false and the direction is receive. Then, problem is though the text is different, so I'll have to check the well, I guess I could not combine these two arms, but then well, actually the closes will be different anyway. Okay, so then I want a match, don't I? Not an if matches. Match this, because I have different text in there. Unless you could think of a clever way that I would include the text there. That would be really clever, but I can't think of it. That these two lines go here. Oh, thank you for that follow. I appreciate it greatly. And those goes there, and then we have to handle all the other cases, which is to do nothing. Thank you for the follow as well. You guys are awesome. Uh-oh, we're getting a lot of follows at the same time. Sometimes that's bad. Okay, we're good. Yeah. All right. Yeah, thank you again for the follows. So, we verified the mask is correct at this point. Now, decode the opcode. This determines, one, if this is a continuation of a fragmented message, or the first and perhaps only fragment of a complete message, of a new message. The type of message. Actually, it does determine the type of message. Okay, so const EU and AT becomes let. Mask with F. All right, so next is to... What are we doing here? Why am I doing this? Oh, I recovered the payload first, and then we use the payload differently depending on the opcode. So why don't I do this earlier? Why don't I do this earlier? It doesn't make sense why I would do the decode. Why I would decode the opcode and then... This is to recover the payload from the frame. We need to apply the recover the payload from the frame, applying the mask if necessary. Alright, so ultimately I just need a vector, right? Actually, we're always going to just push into the, so I don't need a variable here, data. I don't need that. We're going to be pushing into the we're going to be reusing this this message reassembly buffer, I believe. Yeah, why not, right? So why do I have if roll? Oh, why am I doing that? Why don't I just say if mask? If mask, isn't that clearer? Why did I do I don't know why I was thinking. Okay, if mask message reassembly buffer dot how did I work with this before? Resize. Right. So we might possibly have some leftovers in that buffer, right? Oh, thank you for the follow. We might have some leftovers, but we can compute that outside. And this is message reassembly buffer, not frame reassembly buffer. And then where we're adding is the payload length. Okay, now if... Oh, I only need to do this if the mask is applied, right? Because if it's not, we can just extend it with what's in the frame assembly buffer. Yeah. Okay, let's do this. If we're not applying the mask, it's just message reassembly buffer dot append, I think. And then frame, well, I need to get a Oh, I can't do append. It's extend because we need a slice. Yeah, the slice will be from frame reassembly buffer from header length. It says it down here. Header length to header length plus, whoop, that's the wrong variable. Plus payload length. It's not going to auto-format until I get the compiler errors fixed, so let me do it manually for now. That looks really bad. Can I do this, or will it look really ugly? That looks ugly, but that's okay. It'll auto-format it later. Okay, so then, if it is a mask, we need to make room for it. I don't even need to resize. I just need to reserve, because we're going to push back in there, right? Reserve. Oh, can you reserve without blowing away what's in there? Oh, it's additional. Oh, that's even better. I don't have to say leftover again. We just need to say reserve payload length. Yeah, because we might as well just push it byte for byte. We do the memory allocation up front, though. Okay, so for I in... Actually, yeah, we need the I, because that's what we rotate through the... That's how we rotate through the mask. For I in 0 to payload length. This will be message reassembly buffer dot push. And what we're pushing in, frame reassembly buffer, header length plus I. Actually, wonder if I should just slice the frame reassembly buffer first. That would be smart, right? Let payload equal slice that plus payload length, and then I can use it down below as well. Like this. Oh yeah. And then I can just say payload I. XOR. And then if I had another slice, this would be nice. If I had another slice, this would be nice. Slice this from header length -4 to header length. Right? So it's the last 4 bytes of the header. I think. And then I can just say mask bytes. Slices are awesome. Without slices in C++, I had to do this header length plus and minus calculation all the damn time. Okay, that's it, right? Okay, we've got some compiler errors to deal with. Right, it's decoding the opcode. So I want to just match the opcode. And opcode ping is going to lead us down the path of destruction or something, right? And then the default, let's just, yeah, we'll keep the default case, which is unknown opcode. So we're going to make an error out of that, right? Return some kind of error. Bad frame, unknown opcode. You do a zip and a repeat iter for that. Oh, brilliant. I'm sure Musin would like that too. Iterator pure, so I could say something like payload dot iter dot zip with mask bytes iter cycle dot for each. And then we'll get 2 things, right? We'll get byte and mask byte. Well, payload byte and mask byte. And it's just the push in there, right? Oh, could we do this with an append? Ooh, that's even better. Append, because append takes an iterator. No, extend. Extend takes an iterator. Yeah. And then this just gets reduced to payload byte XOR mask byte. That's cool. Why didn't I think of that? That's even better. Look at that. Except for I screwed it up somehow. I forgot the little pipe there. And, okay, this looks broken, so let me fix it. What did I do wrong here? You want map, not for each? Don't I want for each? Oh, yeah, you're right. I want map. Yep. I was going to do for each push, but you're right. I switched mid-stride to do map. Okay, so what's wrong here? Am I missing some syntax? I think I'm missing something. Blah, 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 blah. Oh, I'm missing the end of that extend. There we go. That looks really nice. I like that. Now, will someone reading that be able to figure out what the heck I'm doing? It might be hard, right? Because you have to know what zip means. And you know, we need to know what cycle means. That might be a little bit difficult, but hey, why, with Rust, we want challenges there, right? Okay, so opcode. Yes, so I have send frame, but I don't have a way to do it from here. What I need is to pass along the sender. Let me just mark this as to do. To do, send, ping, a pong here. Okay, and then the event is now going to be using this channel. I mean, not channel, this DQ. Look at that. Look at that fancy DQ with the waker. All right, so then we're going to want to get into our receive messages and use it at this point, right? So let receive messages lock dot expect. I've done this before, so let me just copy paste it. The last holder of the receive messages panicked. That's what that means. All right, and then with that, we're going to say receive messages dot queue dot push back message of some kind, and then if let some waker equal received messages dot waker, then waker dot wake, and we are done. It didn't like that because I need to produce something or do that. Yeah, I think that was it. Okay. Okay, there's no break there. We don't have breaks. All right, so message isn't fully constructed yet. What do I need for a message? Oh, I need to say message ping and give it a vector. Okay, message ping and give it a vector. So that's our payload. Payload 2vec. Done. It's beautiful. Okay, I have some compiler errors though. Oh, this is not beautiful. That's beautiful, but what's this? Unneeded return statement. Wait a minute. Didn't we have this in a loop? Oh, I refactored this out. Right. So I don't need this. I can turn this into an error. As long as this is an okay. It'll work, right? And then get rid of the semicolon. Perfect. Okay, what about this error? This error is because I thought I have an... Oh, wait. Do I have another return somewhere? No, that should... Oh, semicolon. Evil semicolon. Evil. All right. So now there's a compiler error down here and receive... Oh, I didn't pass it something, right? What am I missing there? Mask direction. And now it's saying I don't need the parentheses. You are correct, Mr. Linter. And I do need that parentheses. And that is not necessary. Okay, now back up to here. We're chasing the compiler errors right now. Mutable. I always forget to do that. We are definitely going to mutate... No, I'm not mutating that. What the? Oh, this has to do borrow. I need to borrow mute this. Right. Hold on. What's the type of this? Arc mutex. So wait a minute. What did I get wrong here? Oh, and this needs to be marked mute. That's what it is. Got it. Okay, and this needs to be take. And we're good. We're good. It's not a ref cell, it's... What is it? It's a struct. A struct inside of a mutex. So this is sort of like the state that we share between the pushers into the queue and the takers, which is where I implemented stream. Look at my glorious stream implementation. So we also will get the received messages and lock it in order to inspect the queue. If it's empty, we'll place a waker and say pending. Otherwise, we will pop something off the front and say ready. It's nice and sweet and elegant, and I love it. All right, so I have... Oh, we never needed leftover? Oh, that's sweet. I didn't need that at all. Great, one less variable that we need. All right, what else? Oh, right, we don't need that yet, but we will need that later because that comes into play when we get the continuation. If we get a continuation opcode, the fin flag tells us if it's the last or not. For now, ping cannot be the first. It has to be both the first and the last, so that's the only valid ping you can receive. Actually, you know what we should do? We should test to make sure fin is set. But I'm not sure if... Okay, look. I'm trying to end the stream because I need to eat. But as a to-do here, I need to remind myself. Check to see if we should verify fin is set. It doesn't make any sense for it to be clear, since a ping frame can never be fragmented. Not allowed to be. Gonna implement sync for this? I might, yes, but I wasn't ready to yet. So instead of implementing sync, I just have a top-level API. Let me show you. It is, where is it? Did I collapse it somewhere? I collapsed it. I have a top-level API. Why is that pub? Oh, that's pub, but only internally to the crate. It's actually made by a builder. But once you build it, I just have a top-level API called ping, and there's going to be other methods like text, you know, to send a text message, and binary to send a binary message, you know. So rather than having a sync with an enum that takes which kind of message, I'm just keeping it simple for now. You can use pubcrate to express that. So yeah, tell me if this is good or bad, but the way I've done it is, I think of this as, this is our contract with our parent. So being in a submodule called WebSockets.rs, called WebSockets, we're saying to our parent, which is the crate, hey, make this available to the rest of the crate at least. And then we go up one level, and we see that the crate says it exists, and also says that we're going to pull into the crate level the mask direction. That's for other modules to use. And we're making WebSocket public. Oh, you know what? That does expose the new, doesn't it? Shoot. Oh, maybe this is where I got it wrong. Maybe you're right. I need to say pubcrate here. Pubcrate, so that, because I want it to be available to the rest of the crate, but not externally to the API. Is that the correct way to do it then? If I did pubcrate, it wouldn't be visible outside the crate. I want this to be visible for the builders. The way the builders work is, these are the tests for the builders. If you, opening as a server is the easiest case. So there's a public API for opening it as a server, and you give it the two parts of the connection and the HTTP request, and it gives you back a WebSocket and a response. So if the request is all valid, it'll generate this response and then call new. So this is the only thing, this and the client one builder are the only things that are allowed to call the new. This is incidentally where we say which direction is supposed to be masked. It's receive for a server socket, and the client builder's finish open will set a transmit for the mask direction. Pub super limits it to the parent. There's also... So maybe I do want pub super because it's not as strong. Yeah, let's do that. I don't like making overly strong assertions. If we just say pub super, then it's like, give it to my parent and let them figure out how visible it is, right? And then, oh, but then to make it descend back down, it would need to be crate level, right? Because I can only say pub or not here. I can't say, okay, now take function new and give it down to builders. Super is stronger than crate. More restrictive, right? It's saying that only my parent can use it. It would have to be re-exported to use it elsewhere, right? More restrictive, yeah. So I don't. That's overly restrictive. I need to actually have it go back into builders. I guess the other way to do it would be to in builders. I could say use crate WebSocket. Right now I'm just having it go up to its parent. I hate using the use crate if I can avoid it. All right, anyway, am I done? Am I ready to try this? I can at least see if anything's unimplemented. Let's try it out. What's the worst that could happen? Why do I have a bookmark there? I don't know. The bookmark should actually be on this one. Here goes nothing. It failed. Worker message dropped before it could reach the worker thread. Oh, connection is broken. Okay, that's bad. The connection should not have been Oh, wait. It might have processed one message and then processed the second message and then fallen out too early. Yeah. Okay, let me see if that happened. If so, that's a problem with how I made my test rig here. So... wait a minute. Yeah, let's print stuff here. So let's print here. Print line. Receive frame. Ping. Some string. Payload. How do you do this? It's like, is it string or stir? To, I can't remember this. The one where I can convert to a string, lossy. Actually, it should be UTF-8. No, ping is allowed to not be UTF-8, I think. Anyway, I always forget these things. It's like lossy. String from UTF lossy. There we go. Yep. String from UTF. Through experience comes memorization of these things, right? Yeah, from UTF-8 lossy payload. Okay, and then we should also print something on receive frame, right? Print line receive frame got some number of bytes. And so that is frame reassembly buffer length. Actually, it's not that we got it. We actually have a frame if we get to that point, right? And then maybe another one down here. Like bad frame. Receive frames. Oops. Bad frame. And then let's have another one when the future loop exits out. So let's, out of an abundance of wanting to debug, let's say receive frames begin and receive frames end. Although I do have these early returns, so maybe I do a break instead of a return, and then I'll see that. That would probably be smarter, right? Yeah, I have this break here. Let's, instead of returning, let's do a break. So we'll see that happen. And that's probably, that's enough. That's enough debugging for one moment. Oh, my bookmark got moved. Ah! Run the test. Okay, what do we get? Connection broken. Before it even got a single frame. Huh. So receive bytes was an error. I'd like to see what that error is. So, wasn't there a way to, like, inspect? I can't do it with the result, can I? Map error. Oh, I see. Yeah, thank you. So many points I should be giving you. Map error. Basically to itself, but have a side effect, right? Print line frames error. Some error. And it probably will need to debug that guy. Can he not be debugged? Oh, it's just a warning. What's it telling me? Complex. Let's just screw that. That's fine. What? Why is it here? I don't know. Run it again. Connection closed. Interesting. So that's if we get a 0 back out. That we shouldn't get if I did this right. The way it works is we make a receive mock connection, and I put something in there, and then close. What does this close do? It marks it as fused, which, oh, maybe it's fusing it too soon. Oh, that's what it is. This fused is to say, like, it should return none. Okay, that's what it is. Fused. It's it should be only if it's empty and fused. Right here. This fused should go if it's empty. Else, wait. Yeah. All right. So how my mock connection works is we get access to our shared state between the front end and the back end, and we look at our input vector. Right? It just kept it simple. It's a vector of buffers. If it's empty, if we've fused, basically if we've said there's going to be no more, we've closed our end, then we emulate an end of file. Otherwise, we hold on to their waker and say pending. If it is not empty, we're going to try to take what we have and write it into the buffer that they provide up to the amount that they have room for, and then return the number. So obviously it didn't. I think it fused too early because I have a input and then immediately close, which sets the fuse, and blew up too early. Let's run it again. Oh, interesting. It's hosed. Do we have a deadlock? Do I have a wait while holding a mutex, maybe? I didn't think I did. Using RAII can help with adding debug print statements when you have early returns. Oh, something that prints something during a drop? That's my guess is what you're gonna have me do. Yeah, you have an implement drop for logit. Yeah, that's nifty. Also, what was nifty was the one you gave me earlier about making sure some structure implements a trait. That was a nifty trick. Thank you for the nifty trick. I like to stash nifty tricks to study later and learn from. Okay, so obviously I got a deadlock somewhere. It's when we're in reading more data, right? Is it that our waker is never called? So what should this do? This should call read on our mock connection, right? Because if it got out of there, then it would have done something and printed something, or gotten an error. It would have printed something. So obviously it's stuck. Its waker isn't being called. So maybe I need to debug more about what's going on with the waker. That's here. So the read should make its way into poll read, right? So why don't we just print stuff here? Print. Let's do it while we have the mutex so we don't, like, step on each other. Poll read. We want bytes, please. Please. K, thanks, bye. Because I am kind of nutty when it's the end of my stream. Bufflin, right? Okay. Poll read. Oh no. It's empty. Drat. The fuse has been lit. Okay, otherwise, going to sleep. Now. And then, well, actually, we should say, come back tomorrow. All right, and then, if we get here, we should say, we got bytes for you. And I might as well move that down to here and say total bytes read there. All right, and then where I wake the waker, we should say stuff, right? So that's on the front end of the back end of this, right here. So this is pub WebSocket input, feeding the WebSocket bytes, data length, right? And then we can say, hey, we have a customer waiting. Else. Should put this on the other side of the lock too, right? Yep. Else, it's very lonely here with nobody waiting for data. All right. Am I using Arc Waker? No. I'm just using the waker that they provide. The they being my own code. What would it be? Whatever waker is provided by the read extension, whatever this does, this class in futures, whatever futures provides is going to be providing the waker. We're just stashing the waker that they give us through the context. There, yeah, the waker from the context. So maybe this doesn't work because I don't understand how to do it. I was following along what they did in the book. Do I still have that open? Yeah, right here, where they say this is how you wake it, and then how you stash it is you just clone the waker and stash it. That usage is fine? Okay. Phew. Let's run it and see what happens. Where's my terminal? I don't know why it didn't give me terminal right away. Oh, because I'm not using the terminal. What am I thinking? I'm not using the terminal. I'm using my bookmark and hitting run test. Well, wait. It blocked there? It should have printed something, right? Wait a minute. We want in here. It should have printed. Oh, is it getting stuck in here somewhere? Oh, infinite loop here. I never checked this. Yeah, we should. Okay, let me look at this code. There's probably something stupid I'm doing in here, right? If the buffer is empty, then we're done, right? Otherwise, we check to see if we have something in our queue. If we don't, oh, that's the problem. That's it. We don't have an else here. If we reach this else, then we gave them something, right? So we need to break. So just to confirm that, let me print out some stuff. So this would be they can take blah more buff lane. All right, and then this would be we gave them bytes read more. And then let's just for kicks, we can say so much for that buffer. No argument. Otherwise, we're going to say there are blank bytes left in the buffer. And I'll print after we drain it the length. All right. But then I also want something for the break. We ran out of buffers. But they still wanted more. Okay, I think that's probably it. It's just my silly code causing it. It's not Rust's fault. It didn't compile. I have a compile error. Where? Oh, the test didn't even run. Oh, it ran something. Okay, it did something. There's a lot of things happening here. So WebSocket info is very lonely here with nobody waiting for data. Right, so that means we pushed in a message, right? Then receive frames began, and it tried to read more. They asked for 64K. They can take more. We gave them 8 more. So much for that buffer. They can take that much more. We ran out of buffers, but they still wanted more. We had 8 bytes for you. Received 8 bytes. We now have 8. Next frame is 2 header bytes, 6 payload, 8 bytes. Ping, hello, ping world. That's correct. Reading more data. I should have put that in quotes. We want 64K byte space. Oh no, it's empty. Drat the fuse has been lit. Connection closed. Connection broken. End. What did we try to do on this line? Oh, we're trying to drop the WebSocket and it already exited. Oh, that's right. Okay, then I know what the problem is. We prematurely exited the worker. The worker is not supposed to abandon all hope, right? We should not do this. It should be, we need to join this future completely, but also do this one. So how am I going to do that? A join, I guess? Yeah, I think I need a join here. A panic and drop will abort the process instantly. Yeah, we don't want a panic and drop. The drop is supposed to, the drop assumes that the worker here is still running, and it's supposed to, the worker is not supposed to live longer than, well, the worker is not supposed to exit early. It exited early. We saw the exiting, right? Yeah, that we shouldn't see until during drop, because I wanted the drop to do the join in a clean way by sending the exit message along the channel. In fact, that's the message we got in the panic, right? It was dropped. Yeah, dropped before it reached there. Exactly. So I don't want that to happen. I want it to actually wait for the exit. So the way I have this set up is exit is supposed to generate an indication that we should stop. That means I need to redesign this, because this is the only reason we would ever stop. If we got an error sending the frame, we need to drop the connection, but keep the worker going, sitting and waiting for an exit, right? Either that, or I can allow exit to never be received. Yeah, why would I need to run the worker thread if there's no more work for it to do? Yeah, why don't I just relax the exit requirement? I'll relax the exit requirement. So that basically means we don't need to expect that. We can unwrap or this. And I'm going to say this can fail if the worker stopped early due to the connection being dropped, for example. Or connection being lost, for example. Yep. Changing my requirements. There we go. It still freaks me out how Rust FMT just decides, oh, I'm going to unfold that now. Okay. If I get this to work, then it's dinner time. Ah, it didn't work. We got oh, because I'm still waiting for the pong to come back. Yeah, I'm still waiting for the pong. I'm blocking on the reader. Oh, no, that's different. Okay. That's a different problem. This is what am I saying? The stream never terminated correctly. Oh wait. I don't have any way to tell my implementation of stream to terminate early. That's probably what it is. Yeah, this just keeps looking at the this receive messages there. I need there to be a way to terminate this. Q. I need to have some kind of flag in here, I think. Let underscore equal send. You adjust the result, let equal send. Is that the last thing I changed here? Oh, I see. And just eat the error that way, rather than unwrap or. So just let that equal that. Yeah, I suppose. That's cleaner, I like that. Let me give you a point. I guess I felt like I needed to do something with the error explicitly. This is just saying, I'm just going to eat it, and I'm going to drop it right away. So go ahead and give me an error. I dare you. Right? Okay. So I need a way of signaling to the stream implementation that there's not going to be any more data. I think I know how to do that. At the end of my worker, right here before we exit, we have access to the received messages, right? Oh, we gave it to them, though. Oh, I know what I can do. This, yeah, we can give them a clone. And then we have the original here, and we can do something like lock expect why write something when you can copy it? The last holder of the received messages panicked dot fused equals true if, okay, I need this into a block. Let receive messages equal, this is going to be dirty. I hope you don't mind if I make it dirty right now. It's going to say, set the fuse, and it'll say if we have a waker, take let some waker equal, then waker wake, wakey wakey. And I just need to add this fused thing, right? So there, and fused bool. And then where we make these messages, or where we make the receiver, it starts out as false. And then in the stream implement, oh, I have another error. I need to do a mute, don't I? Yes. Mutex guard, okay. When you move to async mutex, you won't need those expects. Yeah, you're right. They will become futures that never complete, right? Because we can't get the mutex because whoever was holding on... Actually, no, we would get the mutex, right? Because if you panic, your future would just never complete and everything would be dropped from your state. So much cleaner, right? That's true. Another reason to move to async mutex. Add that to my... Actually, that already is on my list. Reminder. Really try hard to move to async mutex. Well, actually, we learned that it's async lock. Formerly async mutex. Did you know that, Musin? Someone in chat realized that if you look up async... Where is it? Async mutex, and it looks like it's recent, but if you go to their GitHub, it's actually the GitHub for async lock. And there's another crate out there called async lock. And it looks like it's pretty much the exact same thing, only it's got... it appears to have everything async mutex had, only it matches what the GitHub is now. It's mutex plus read write lock plus semaphore plus barrier, right? But the old mutex still refers to... Oh, wait a minute, it's different now. It didn't say that before. I must have been on an old version of the crate. Okay. Oh, no, this is what it is. Their crate documentation is old. When you go into their API reference, barrier isn't there, but they still say barrier out here. Right? For async mutex? Yeah, async mutex shows async lock with all of these listed. So it was really confusing. The read... Yeah, you're probably right. It's picking up the readme from the same repository. So they have two crates pointing to the same repository. If I was the maintainer and if I wanted to structure it like that with a crate and a subcrate, I'd probably have two repos just so that the readmes would be different in the crates page. Anyway, that's besides the point. I should move to that. In the meantime, what am I going to do here? I need to actually respond to that. So that is in the poll next. Here. If we wake up and it's not empty... No, if it is empty... If it's fused, then ready none. Else, get a waker and it's pending. And that might fix it. Because then we will break out when it gets dropped. So, try it again. Okay, now what? Output is some. Was expected here. Oh, the pong message. Okay, cool. We got past this was okay. So now we just need to receive back the pong. Okay. The problem is I didn't provide a mechanism for one task to send the other one instructions. So in order to do that, I think I need to clone the... I need to go to worker. Worker, that is. Here. And we only have the receiver. I need the sender because I need to give the sender to the processing RX in order for it to be able to send things, right? Either that or the receiver needs to have access. No, the ultimately we want it to go through handle message and have it do a send for us, right? Because it owns the transmit end of the connection. So yeah, I think I need the worker to get work in sender also. Yeah, and we can clone that. We can clone the sender, so that's not a big deal, right? We don't have to worry about cloning the send. Where is it? Spawn. Here it is. I can clone the sender, no problem. Like, make this one a clone or something, right? That should be fine. Okay, now the worker thread can send itself messages if it wants to. I'll fix that later. So back in worker, async lock, ETL, part of the small ecosystem where everything is a tiny component that's a la carte. I like that system. I need to move away from async standard because it's the opposite of that. It's like pulls in everything, and I only really need a few things like TCP stream and timers and timeout, that kind of thing. Okay, I'm over time by an hour. I need to end soon. I think what I need to do is pass him the sender, borrowed, mutably, work in sender. The idea is that the frame receiver needs to be able to send a pong in response to a ping. Deeper in here, in receive frame, right? If we get a ping, we need to be able to send a pong. And the way we do that is to send a message to the sender of the channel. So I put it where? I put it as the last thing. Okay, so the last thing. So this is, we're borrowing mutably. No, I'm not borrowing mutably. It gets it. We give it to them, right? I don't need to borrow that. In fact, I don't want to borrow that. It gets a copy. Correct. Okay, so it gets a copy. It's, right, the inner one that needs to borrow it mutably. The receive frame here. So this one borrows mutably the work in sender. And this goes there. Okay. I had some compiler errors because why? Cannot borrow it as mutable. Oh, it needs to declare it as mutable. Sure, you can mutate it. Please feel free to mutate work in sender. You have my license. Standard, async standard is the full meal, yeah. I don't want the full meal, I think, because I'm making libraries. It makes sense to make a program consume the full meal, but if I'm making libraries, taking the full meal then forces that meal on everyone else, right? I don't want that. Futures has its own mutex, by the way. It's really... Oh, it does? Well, that's what I've been using, I think. The mutex I've been using is from standard, yeah. I'm not using the futures mutex. These are the only things I'm using from mutex. These are the only things I'm using from futures. The channel stuff, the executor for block to glue threads and futures together. The extensions, because they're really convenient, and stream. Yeah, I'm still using the standard sync mutex. So you're saying the futures has its own under futures lock. Oh, I read your message the wrong way. I thought you said, okay, I don't know what I thought you said. You're saying futures has its mutex too. It's pretty nice. If I'm pretty much bringing in the full futures crate. Maybe I switch from standard mutex to futures mutex. What does it do? Pretty nice if you're already bringing in. It doesn't have those. Yeah, well, don't use those anyway. It does have bylock, which is unique. I wish it was available outside the full crate. The mutex set only has 2 owners, so it can do read-write lock stuff more efficiently. Well, yeah. Cool. Let me take your message that says futures has its own mutex. I'll make that another piece of homework. Thank you for that. See, chat, I hope that you're learning as much as I am. Okay. I need to wrap things up. So, now that I have in receive frame a worker that we can borrow, I can actually use it to send a pong. So that's what I'm going to do here. Worker in unbounded send, worker message, send. And what does a send need? It has a fin, an opcode, and a data. Yeah, we can do this. We can do that. No problem. The fin is yes. The opcode is opcode pong. The data is the payload. But I want to deliver it up, so that means I'm going to want to clone for the pong. And I can't do that. Why? Oh. It's not a vector. What is it? Ah. Okay. Then it's to vec. Is it better to do 2vec twice or 2vec once and then clone? I feel like it makes more sense for me to do it once. Because we know we have to do it anyway, and then here I can do a clone, and then here I can just let it own it. I feel like that's better. What's the problem here? Oh, that can fail. So expect similar thing to where we do unbounded send. So worker thread dropped its receiver. Yeah, that should never happen. From this level, because we are in the worker thread. Oh, wait. This one we're allowing. This one we should allow too, right? Yeah, this one, this is not true anymore, right? Because the worker thread can exit early. So what do we do if someone tries to, if we internally call send frame? Well, hold on. Who calls send frame? Ping, for example. If we do a ping and, what if someone does a ping and the connection's been dropped? Do we just ignore it? I think I will, but I'm gonna have a note here to do. Right now, let's say this can fail if the connection has been dropped and the worker thread has exited before the user tries to send a frame. In this case, right now, we simply ignore the request to do. We might want to instead return an error to let them know. Right now, like, I'm just trying to get this working, and the C++ code actually did do a silent discard, so it's going to be the same thing, right? Let that equal that. Boom. Done. But the to-do will remind me to come back here and revisit that. All right, so then, where was that pong again? Pong. Here. So I don't need a to-do. I still need to check to see if if we're supposed to verify fin is set. I'm not checking that right now. So this we can expect because we are the worker thread. It shouldn't drop its receiver there. All right, so now trying again. Yeah, that keeps moving. I wonder if Rust format does its thing, it interferes with the bookmarks. We're still getting a problem with the output. So the pong is not being sent. Do we actually print something when it sends things? Ping. Oh, maybe not. We should do that. Just make sure it's actually being done. Actually, it might not get done because we're ending early, right? Because of that. Oh, yeah, we can't allow that to happen. Yeah, that's the problem. If we drop our end, then we can't expect to get the pong back in time. So back to the unit test. Unit test is dropping its socket too early. I need to move the drop on the WS, right? Actually, the way this works, the reader owns it, which is a problem, right? Because the moment that this is done, we can't expect to be able to do that anymore. Right? No. When it processed this frame, it should have pushed the other one. Oh, it might have pushed the other one in, and it might be waiting to handle handle the pong, and it doesn't get that far because the other future beats it to the close. Yes. So we can't do that until after we, is this a chicken and the egg problem? It might be. It might be that I need to move the pong receiving up into here. That when we receive a ping, we should expect to receive a pong as well through the back end. Oh, this is going to be complicated, though. Let me think about this. Here's where we send the ping, right? It goes in. Now, the moment we do that, it's possible that it might win the race and the worker will stop, and so we can no longer receive anything back out. So I can't do that. I have to delay that. But if I move it past this block here, this close is what causes this one to complete. So it's almost like I need to move all of that into there as well. I think that's what I need to do. So basically, if we receive a ping, we should also expect that the WebSocket sends a pong which matches it. Yeah, so that's what I'm going to do. I'm going to move this into the other future. That goes here. Okay. So, we're going to say record the ping we received. Expect to receive back the matching pong message, which the WebSocket should send when it gets the ping. So, the problem is this is going to own the backend. Is that okay? No, I need to share it because we need to share. No, that's the RX and this is the TX. This should be fine. It can own that, right? So assert that we get something, unwrap it. It should be 12 bytes. That should be the content. Actually, this should actually work, right? I do have a compiler error about frame. What's the... Cannot find frame. Oh. Frame was something we defined way out here. So... No, I don't need to look at that. It only needs to look at message. Yeah, so we can look. We can use message as long as we get to keep it. I can do that at the end, like right here, and then here we can borrow message, and this would be I. All right, so this is the. Oh, it didn't like that. Something escaped. What escaped? Cargo test. Cargo clippy tests. What escaped? Connection back TX escaped. Okay. So ref cell, put it in jail. If it escapes, put it in jail. Let that equal ref cell new that. And then where we use it inside, I did the wrong one. I put the wrong thing in jail. Okay, where we use that, I need to borrow it mutably. There we go. So that means this doesn't need to be mutable. We use it inside here. But it does need to be, oh, it's mutable there. Yeah, fine. Okay, there we go. Jailed, that's right. That's how we fix things escaping closures. We put them in a cell. Isn't that a nifty way to remember that ref cell is a way to handle that? It's because this closure is being called more than once, right? Which means that it's not allowed to let these things go in and then either get consumed or escape. It's got to be like borrowed immutably. So to borrow it immutably, we put it into a cell and then do runtime borrow mutable. It's all cool. It'll stay in this closure and be happy. It'll be happy in its cell. Run the test. Okay. Did we get further? Actually, that's going to happen, isn't it? No. I wonder if this is just not waiting long enough. I was very aggressive about that timeout, right? Let's bump that up. Just to see if that's what it is. No. Or did it work? It failed. Why? Oh, cannot execute executor from within another executor. How do we get there? Oh, did I do a block on? Did I do a block on inside of that? I probably did. Block. Oh, I can do that, right? And I can do that. What's the deal then? Yes, we got cannot execute. Oh, it's thread receive ping. Right, the test thread panicked. Well, I guess I can see that, right? If I do a debug. Let's see it crash. All right, there's where it crashed. It crashed. Oh. Yeah, we can't do that. We can't, right, I can't do that. I need to make an alternative that's asynchronous. See how the debugger kind of took a dump there? That's fine. It served its purpose. So this is assuming, this is a test fixture problem. It's assuming that we're running in the main thread, not in a future somewhere. So I need to make an asynchronous version of this. So pub async function equivalent of this. Actually, I can put the main, I can make this one the main one, or we just do this. Right? And then this can simply call the other one. Self dot, right? Await. No, not await. Block on that. Yes. There we go. And now I have to call that one from where I had the code running in a future. So that was here. Right there. Async. And I have to await that. Like a good little citizen of the future's land. Is that going to be a problem if I borrow that mutably? It shouldn't be because we don't use the transmitter anywhere else, right? So no one else is going to try to borrow it mutably while we're waiting. That should be good. All right. More problems. Thing is, it's executing everything correctly. It's just not receiving the pong back out. It's this timeout. I'll make that longer. I don't think it's the timeout, though. I think it's not being sent for some reason. Wait a minute, did it even wait? Yeah, it got a none, so it was broken right away. Output is empty, yeah. The output is empty here, if it's an error. Can I, debug that? Yeah, why not? Okay, none. All right. So that means timeout didn't happen, right? Because if we got a timeout, we would get a timeout error, right? Yeah. So it didn't time out. The receiver told us there was nothing left. Wait, that shouldn't happen. Hold on. Blah, 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 blah. That would mean the front end of the connection transmitter got. Oh, it did exit early. Why did it exit early? We didn't close it yet, did we? Wait. Where are we calling close? Oh. Is that it? Yeah, this is racing it. Shoot. Yeah, while we're waiting, it raced the other one. We don't want to close that until this is done. Right? Yeah. Can I move the close inside there? I feel like I should. Yeah, so that means we're going to share the connection receiver front end. I think that's okay, right? Well, wait a minute. It should be, because here's where we execute the future, and here's where we're not going to close it here. Yeah, okay, so actually it can actually, yeah, we can share it. That's fine. So we're going to jail the other guy. Jail them both. Right, and then now that we're done, we can close the connection. So that's this line here, goes here. And we have to borrow mute to close it. And then this has to borrow mute to send in the input to kick off the whole process. Okay, I'm going to need to seriously clean this up later. Yay, it passed. The equals that. Did I misspell something? Close the connection. There's only one connection. I think that's fine. Okay, I had a debug in there, I think. Here it was. I can remove that debug now. All right, and then it's almost dinner time, because I think I got this running now. Okay, let me review the debugging stuff. So, we feed in 8 bytes. It starts processing the message. It hasn't received anything yet. No. It's the other way around. These are racing each other. These two messages are racing each other. So while we're feeding the WebSocket data, the worker starts to process messages. Once we're done feeding it in, it's like no one's waiting for it yet. Then we start to read more data, and it polls and says we can receive that many more, and then it gets 8. Yeah, we already know that the poll read works, right? So we got 8 bytes. We received it. We saw that it's a ping, and we try to receive more data, and it says it's empty. Come back tomorrow. Got a message. I mean, why is it re-entering poll again? Is the waker being woken up? Why is it polling more than once? It should be waiting on my waker. Why did it poll 3 times like that? It makes sense that it would do that, but why? What about this other? Why did it have an extra poll here? Actually, both of these two polls shouldn't happen. It shouldn't come back until I light the fuse or give it more data, which I never do. Is that just a spurious wake up? Can you get a spurious wake up with this system? I'm going to assume that this is a spurious wake up. I could put a delay in there to make sure. So when we drop our connection, that's where we get this, right? So let me put an extra message in there just because I'm curious. We will say print line closing connection now. Print line waiting a bit before closing the connection. And the way we'll wait is with timeout. Standard time duration from seconds. How about 2 seconds? And then comma. Can I just say ready? Future ready? Future's future ready? Or pending? Pending. Oh, wait. There. I can't say timeout. Why not? Type inside async block must be known in this context. Can't infer. Oh. I've run into this one before. I can't infer the type of this, so we have to say that it's a pending that returns a nothing. Right? Or no item. Yeah, and then it's going to say the whole thing I'm ignoring, so let's ignore it. Ignore if it times out. We know it's going to time out. Oh, I can say pending that instead? No, it's just that it can't, it doesn't, I can't, you don't give an argument to pending, but you have to use the turbo fish. Yeah. Uh-huh. Okay, so then, you don't use that crate very often? I shouldn't use it. I should use the async timer instead, but I'm lazy. So I'm using the async standard timeout. All right, so, test again. Come back tomorrow. Okay. I didn't see where it paused, but it should have paused after saying waiting for a bit. Yeah, right there. But I need to run that again because, let's trash this one so there's no, trash all of these. Okay, I want to see that again. It's, okay, so it said waiting for a bit and it went down to there and it paused, right? So this must be when we closed it because we woke up the waker, right? So why is there this extra poll? Actually, that one is also extra. You've been wholly on board the Futures Light, Futures Micro train? Do I need to get on board that train? Okay, I got my homework, and that's even more homework for me. Thank you, Musin. I got it working, though, except for what happened here. Oh, one timeout exceeds the other one, right? So if I remove that wait, it's all good again. Yeah, let's remove the wait. I don't know why I'm getting extra spurious polls, but we're only getting 2 extra polls. I'm going to guess it's some kind of spurious wake up of the polling system. Oh, I wonder if it's because of the select that we do in the worker thread. Anyway, let's just say that, because this will pass the test. Correct. Yes. All right. I think I'm gonna make this another quitting while I'm ahead, a quitting while I'm ahead time, and work on this more tomorrow. So tomorrow, what am I have to do? I'm going to have to clean this stuff up, and I need to implement pong text binary message reassembly, and then try to put it through the rigor of the test test vectors from the link we got yesterday, the Autobahn WebSocket test suite, right? So I'm gonna do all that tomorrow, I think. Hey there, TS Just. Welcome. I'm just leaving. Sorry. You just wake up? No, it's in the middle of the night. What the heck? Why are you up so late? Oh, you're saying bye. You've been lurking. You've been lurking this whole time? Well, thank you for the lurk, TS Just. I'm gonna go see if anyone else is doing Rust right now. Like always, I will post the link in just a second. This is where I recommend going to see if someone else is streaming Rust. I got it working, yeah. I did get it all working, 715209. See? A test passed. I have a lot of stuff to clean up, though, that we're printing. A lot of print statements. I mean, it's interesting to see the inner workings and the timings of things, but we don't need to see it when we're done now, right? Okay, so I'm streaming right now in that team, and so is Primogen, but Primogen is not doing Rust, right? He's still doing his JavaScript or Lua stuff, probably. Vim Deathmatch. So let's see if there's anyone else that I follow, maybe. Check out Event Listener, by the way. Will do. Another point from Musen. Thank you for the homework. We can zoom out. That's too zoomed in. Too much homework. For doing async notifications between tasks and futures. Ooh. So I wouldn't have to do the one-shot stuff and the channels that I use now? Kind of feel like I'm doing a low-budget hack when I do that. Reminds me of Node.js. Okay. There actually are a lot of streamers going on right now. So I have some choice to make. How would you guys like to see someone learning JavaScript? Pair learning. A friend of the stream, the Alt F4 stream, Black Glasses and Atoda. Black Glasses is teaching Atoda JavaScript right now. You missed me again, Cthulhu. Sorry, I've been going for the last 6 3/4 hours, though. Oh, have a good night, Cthulhu. Yeah, I'm sorry that our time slots don't quite match up. I'm trying to hit all the different time slots, though. This is about as late as I can go. Maybe I would have to do is start streaming, like, in the mornings again. Another thing to check out. Hold on. Rust implementation of event counts. Oh, that's... Tab that in. Okay. Got it. I think we're going to rate Black Glasses, or the Alt F4 stream, teaching his friend Atoda JavaScript. So let me get that ready. Here is the link. And if JavaScript isn't your thing, sorry about that. There are plenty of other science and tech streamers doing whatever language you can find. And I'd have to pick somebody, so we're going to rate Alt F4 stream today. Hopefully I'll be back tomorrow. Actually, I might not be back tomorrow because it's Thursday. If I'm not here tomorrow, I'll be back on Friday. I hope you guys all have a great rest of your morning or evening. And yeah, thank you, 7152. It was great that you were here. And yeah, stay safe and stay learning. Don't stop learning. I will see you guys either tomorrow or the next day. So take it easy. Bye. Bye-bye.